Langchain Google Genai Chat Models Summary. None. This section provides a comprehensive overview of utilizing Google Genai chat models within the langchain framework. Inputs. This signifies the user's query or prompt that the chat model will process to generate a response. For example, a user might ask what is the capital of France. This refers to any relevant background information or context that should be considered by the chat model during response generation. This could include factual data, previous conversation history, or any other pertinent details. For instance, if the user query is what is the capital of France, the context could be a previous conversation about European geography. Outputs. This represents the generated response from the chat model based on the input and context provided. The response will be a coherent and relevant answer to the user query. Continuing the example, the response could be the capital of France is Paris. Steps. This involves initializing the langchain library, which is essential for managing and interacting with the Google Genai chat model. This step entails loading the specific Google Genai chat model desired for the task. Google offers a variety of chat models, each with specialized capabilities and strengths. For instance, you could choose a model designed for conversational tasks or one optimized for factual information retrieval. This involves setting up a communication channel or interface between langchain and the Google Genai chat model. This ensures that user input, context, and model responses can be exchanged effectively. This involves actually executing the chat model, processing the input and context, and generating a response. The model's capabilities and the quality of the response are directly influenced by the chosen model and any provided context. This step retrieves the generated response from the chat model and makes it available for further use or display to the user. Prerequisites. This refers to a Google Cloud project, which is a workspace where you can manage and deploy cloud resources. A Google Cloud project is necessary for accessing and utilizing Google AI services, including Google Genai chat models. For instance, a project can be created on the Google Cloud Console. This represents the unique identifier assigned to your Google Cloud project. It is used for accessing and managing resources within the project. An example of a project ID is My Project 123. This is an application programming interface key that grants access to Google Genai services. It acts as a credential that authorizes your application to interact with Google's AI infrastructure. A Genai API key can be obtained from the Google Cloud Console. This refers to the specific value of your Google Genai API key. It is a long, alphanumeric string that should be kept secure and confidential. This is a powerful Python library for developing and deploying language models. It provides a flexible framework for working with various AI models, including Google Genai chat models. Langchain is installed using pip install langchain. This indicates the version of the langchain library you are using. It is important to ensure compatibility between langchain and the Google Genai chat models. For example, you might be using langchain 0.0.21. Fine-tune parameters. This parameter controls the randomness or creativity of the model's generated response. Higher values lead to more unexpected and potentially novel outputs, while lower values result in more predictable and conservative responses. For instance, a temperature of 0.7 might produce more diverse responses than a temperature of 0.2. This parameter limits the number of possible responses considered during generation, potentially improving efficiency but potentially reducing diversity. A higher top K value allows for more options to be considered. while a lower value restricts the pool of potential responses. For example, top K10 would consider the 10 most likely responses. This parameter determines the probability threshold for selecting words during response generation. Higher values allow for more unexpected and less likely words to be included, while lower values favor more predictable and common words. For instance, top P0.9 would select words that have a combined probability of at least 90. Challenges and fixes. This refers to scenarios where the provided API key is invalid or not properly configured, preventing access to Google Genai services. This suggests verifying the accuracy of your API key, ensuring that it is correctly entered and authorized within your Google Cloud project. This indicates situations where the requested Google Genai chat model cannot be found or loaded. This recommends checking the spelling and availability of the desired model name. It is crucial to ensure that the model name matches the one provided by Google Genai. This addresses issues related to how context information is provided to the chat model. Incorrectly formatted or incomplete context can lead to inaccurate or irrelevant responses. This emphasizes the need to use the appropriate context format for the specific Google Genai chat model. Refer to the model's documentation for guidance on how to structure context information effectively. This relates to limitations on the number of requests that can be made to Google Genai services within a given time frame. Exceeding these limits can result in temporary blocks or service interruptions. This recommends implementing rate limiting mechanisms within your application to avoid exceeding API quotas. This involves controlling the frequency of requests to prevent overloading the Google Genai servers. This refers to managing the memory consumption of your application, particularly when handling large amounts of data or complex conversations. This suggests utilizing memory strategies to optimize resource usage. This could involve techniques like caching, data compression, or efficient memory allocation to minimize memory strain. Langchain Fireworks Chat Models. Chat Fireworks Summarization. Chat Fireworks is a specialized langchain model designed for interactive storytelling and creative writing, leveraging the power of generative artificial intelligence to bring narrative experiences to life. It combines the capabilities of large language models with the flexibility of the langchain framework, allowing users to create and engage with dynamic, interactive narratives. Inputs. User prompts. The model accepts natural language prompts from users, providing instructions, questions, and creative input for the story to unfold. These prompts serve as the starting point for the narrative, guiding the model in generating content that aligns with the user's intent. For example, a user could provide a prompt like "Write a story about a detective who discovers a mysterious artifact in an old attic" to initiate the narrative. Contextual information. Chat Fireworks can be provided with existing story elements, character details, or world-building information, enabling the model to weave its narrative into a larger context. This contextual information can include details such as character names, relationships, setting descriptions, or even pre-existing plot points. By incorporating this information, the model can generate content that is consistent and relevant to the established narrative world. For instance, if a user provides a backstory for a character or a description of the setting, the model will use this information to create dialogue, actions, and descriptions that align with the provided context. Outputs. Narrative text. The model generates engaging and coherent story content, delivering dialogue, descriptions, actions, and plot points that contribute to the ongoing narrative. The generated text forms the core of the story, providing users with a dynamic and evolving narrative experience. For example, the model might generate dialogue between characters, descriptions of the setting, or actions that move the plot forward. Interactive elements. Chat fireworks can incorporate interactive components, such as choices presented to the user, allowing for a more immersive and engaging storytelling experience. These interactive elements provide users with opportunities to influence the direction of the story, making the narrative more dynamic and engaging. For example, the model might present a user with multiple options for the character's next action, allowing the user to choose how the story progresses. Steps. Prompt interpretation. The model analyzes the user's prompt, identifying key elements, themes, and potential directions for the story. This involves understanding the user's intent, identifying relevant keywords, and recognizing the overall narrative structure that the user is trying to create. For example, if a user prompts write a story about a magical creature that lives in a forest, the model will analyze the prompt to understand that the story should involve a fantasy element, a specific type of setting, and potentially a conflict or challenge for the magical creature. Narrative generation. Based on the input and its understanding of the narrative context, the model generates text that advances the story, introduces characters, develops plot lines, and creates vivid descriptions. This step involves the model's creative core, where it uses its knowledge of language and storytelling to generate coherent and engaging content. For example, the model might generate a description of the forest, introduce a magical creature with specific abilities, or create dialogue between characters that reveals conflict or plot points. Interactive response. If the model is designed to be interactive, it provides the user with choices or prompts for further input, allowing the user to influence the direction of the story. This step ensures that the user remains actively involved in the narrative, shaping its direction and experiencing a more personalized and engaging storytelling experience. For example, the model might ask the user, "What does the magical creature do next?" offering multiple options for the user to choose from, allowing the user to influence the path of the story. Prerequisites. Large language model. A powerful generative artificial intelligence model, such as GPT-3 or similar, is essential for chat fireworks to generate coherent and creative narrative content. These models are trained on vast amounts of text data, enabling them to generate human-like text, understand context, and respond to prompts in a creative and engaging way. Examples of commonly used large language models include GPT-3 from OpenAI, Jurassic 1 Jumbo from AI21 Labs, and Lambda from Google. Langchain framework. The langchain library provides the necessary infrastructure for connecting and managing various components, enabling the creation of complex chatbot-like applications like Chat Fireworks. Langchain acts as a bridge, enabling the integration of different components like large language models, databases, and APIs, allowing for the creation of sophisticated applications like Chat Fireworks. Examples of frameworks that can be used alongside langchain include Hugging Face Transformers, which provides access to a wide range of pre-trained language models. Fine-tune parameters. Story style. The model can be fine-tuned to match specific narrative styles, such as humorous, suspenseful, or realistic, influencing the tone and content of the generated text. Fine-tuning allows users to tailor the model to specific creative preferences, ensuring that the generated content aligns with desired storytelling styles and conventions. For example, if a user desires a humorous story, they can fine-tune the model to generate text with witty dialogue, comedic situations, and a light-hearted tone. Character development fine-tuning parameters can be used to control how characters are developed, ensuring they are consistent, engaging, and fulfill specific roles within the story. This allows users to create characters with distinct personalities, motivations, and relationships, contributing to the overall narrative depth and realism. For instance, a user might fine-tune the model to create a character that is brave and impulsive, or a character that is introspective and cautious, shaping their interactions with other characters and their impact on the plot. Challenges and fixes. Inconsistent narrative flow. Chat fireworks might struggle to maintain a consistent narrative flow, especially with complex prompts or evolving storylines. This challenge arises from the inherent complexity of managing a narrative across multiple prompts and user interactions. Potential solutions include incorporating improved training data that focuses on consistent storytelling techniques and developing advanced contextual memory mechanisms that allow the model to retain and reference past events and information. Limited creativity. While powerful, the model may occasionally generate predictable or repetitive content, especially in situations where it lacks sufficient guidance or context. This is a common challenge for generative AI models, as they can sometimes fall back on familiar patterns or lack the contextual knowledge to generate truly novel and unexpected content. Potential solutions include increasing the training data with diverse and creative examples, promoting exploration of new ideas and themes, and employing prompt engineering techniques to guide the model towards more original and surprising narrative elements. Langchain Google Genai Chat Models Summary. None. A detailed explanation of Google AI chat models accessible through langchain, a powerful framework that enables interaction with large language models. Inputs. Text provided by the user to the chat model, serving as the initial query or request for information or action. Optional contextual information that enhances the user prompt, allowing the chat model to generate more relevant and accurate responses. For instance, if the user prompt is "What is the capital of France?", providing the context European country can help the model understand the scope of the question and avoid ambiguity. Outputs. Text generated by the Google AI chat model in response to the user's input, incorporating the provided context and leveraging its vast knowledge base. Steps. The user's prompt is transmitted to langchain, a framework that facilitates interaction with various AI models, including Google AI chat models. Langchain initiates a communication with Google's Application Programming Interface API dedicated to AI chat models, relaying the user's prompt and any contextual information. The Google AI Chat API processes the prompt and context, leveraging its powerful language understanding capabilities and vast knowledge base to generate a comprehensive and relevant text response. Langchain receives the generated text from the API and returns it to the user, completing the interaction cycle. Prerequisites. An active Google Cloud account is necessary to access and utilize Google's AI chat models. The account enables users to manage billing and access the necessary resources. A unique Google Cloud API key is required to authenticate requests to the Google AI Chat API, ensuring security and tracking usage for billing purposes. Langchain is a framework that facilitates interactions with large language models, including Google AI chat models. The Langchain library needs to be installed within the Python environment to enable communication and utilization of these models. Python is a versatile programming language that provides a robust environment for interacting with AI models, enabling developers to execute code and integrate Langchain functionality. Fine-tune parameters. A parameter that influences the creativity and randomness of the generated text. Higher values increase the likelihood of unexpected or less predictable outputs, while lower values tend to produce more consistent and predictable responses. This parameter controls the number of most likely words or phrases that are considered during text generation. Higher values broaden the range of possible outputs, while lower values restrict the generation to a smaller set of highly probable candidates. A parameter that influences the diversity of the generated text by controlling the probability distribution of words or phrases. Higher values allow for more diverse and unexpected outputs, while lower values tend to produce more predictable and consistent results. Challenges and fixes. Application programming interfaces (APIs) often have limitations on the number of requests allowed within a specific time frame. This can restrict the frequency of interactions with Google AI chat models. Implementing a rate limiter helps manage the frequency of API calls, ensuring compliance with API limitations and preventing potential errors or account suspensions. The availability of specific Google AI chat models can vary due to factors such as maintenance, updates, or resource limitations. In case of unavailability, utilizing an alternative Google AI chat model with similar capabilities can provide a workaround, ensuring continued access to AI-powered text generation. Utilizing Google AI chat models involves costs, which can vary based on usage patterns and chosen models. Monitoring usage and selecting budget-friendly models can help optimize costs, ensuring responsible and cost-effective utilization of Google AI chat models. Langchain Google Genai Embeddings. Langchain Google Genai Embeddings is a feature that leverages the power of Google's AI models to generate vector representations of text, enabling efficient semantic search and retrieval. This is achieved by converting text into numerical vectors, which allows for comparisons and relationships between different pieces of text based on their meaning. Inputs. Text data that you want to embed. This refers to any textual content, such as a paragraph, document, or even a single sentence, that you wish to transform into a numerical representation. For instance, if you want to analyze the similarity between two articles, you would input the text from both articles. Outputs. A numerical vector representing the input text. The output of the embedding process is a vector of numbers that captures the semantic meaning of the input text. This vector can be used for various tasks, such as searching for similar documents, identifying related concepts, or classifying text into different categories. For example, if you embed a sentence about artificial intelligence, the resulting vector would likely be close to vectors representing other sentences about AI or machine learning, as they share common semantic concepts. Steps. Text is sent to Google's AI model. The input text is sent to a Google AI model, such as a pre-trained transformer network, which has been trained on a vast dataset of text and code. For example, the text "the quick brown fox jumps over the lazy dog" would be sent to the AI model for processing. Model processes the input text and generates a numerical vector representing the text semantic meaning. The AI model analyzes the input text, taking into account the words, their order, and the overall context. Based on its understanding, it generates a numerical vector that captures the essence of the text's meaning. This vector is a collection of numbers, where each number represents the importance of a specific aspect of the text. For instance, in the fox jumps example, the vector might have higher values for elements related to animal movement and speed while having lower values for elements related to politics or economics. Prerequisites: Google Cloud Platform project with the necessary application programming interface enabled. You need to have a Google Cloud Platform project set up and have the necessary application programming interface enabled to use this feature. This is done through the Google Cloud Console, where you can activate the specific API service that allows you to access and interact with Google AI models for embedding text. A Google Cloud Platform project allows you to manage resources, such as virtual machines, databases, and storage, and provides the infrastructure for using various services offered by Google Cloud. Challenges and fixes: limited application programming interface quota or rate limits. The use of this feature is subject to limits on how many requests can be made within a specific time period. This can be a challenge when dealing with large amounts of data. Increase quota or optimize usage. You can address this challenge by increasing the quota for your project if needed. Alternatively, you can optimize your usage by efficiently batching requests, utilizing caching mechanisms, or implementing strategies to avoid unnecessary repeated requests. For instance, you might process a large dataset of text in smaller batches to avoid exceeding the API limits. Handling sensitive data. When working with text data, it is important to be aware of privacy and security considerations. Use appropriate security measures to ensure the security of sensitive data. You should implement appropriate security measures, such as encryption, access controls, and data anonymization techniques. This involves protecting the data during transmission and storage, limiting access to authorized users, and minimizing the risk of unauthorized disclosure or manipulation of sensitive information. For example, you might encrypt the text before sending it to the AI model, ensuring that only authorized parties can access the decrypted content. Google Generative AI Embeddings Langchain Embedding Implementation. Generate text embeddings using Google's Generative AI service. This implementation utilizes Google's Generative AI service to convert text into numerical representations called embeddings. Embeddings are crucial for tasks like semantic search, similarity detection, and recommendation systems. Inputs. Text to be embedded. The input is the textual data you want to convert into an embedding vector. For example, you could provide a product description, a news article, or a customer review. Outputs. List of embedding vectors for each input text. The output is a list of numerical vectors, each representing the corresponding input text. These vectors capture the semantic meaning of the text and can be used for various downstream tasks, like comparing different texts or identifying related content. Steps. Send text to Google's Generative AI service. The first step involves sending the input text to Google's Generative AI service using appropriate API calls. This service will process the text and generate an embedding vector for it. Receive embedding vectors from the service. Once the text is processed by the service, it will return the embedding vectors as a response. These vectors can then be used for further analysis or integration into your application. Prerequisites. Google Cloud project with application programming interface enabled. Before you can use this implementation, you need to have a Google Cloud project set up and ensure that the Google Generative AI application programming interface is enabled for your project. Service account with appropriate permissions. To access and interact with the Google Generative AI service, you'll need a service account with the necessary permissions. This service account needs to be granted the required roles to access the Generative AI service. Fine-tune parameters. Model to use for embedding generation. This parameter allows you to select the specific generative AI model you want to use for embedding generation. Different models are optimized for various tasks and have different strengths and weaknesses. You can choose the model that best suits your needs. For example, you could select a model specifically designed for text understanding or one tailored for image analysis. Challenges and fixes. Quota exceeded. This error typically occurs when your Google Cloud project has reached its limit for using the generative AI service. To fix this, you can increase your quota for the service or consider using a different embedding model that might have a more generous quota. Application Programming Interface Key invalid. This error indicates that the application programming interface key you are using to access the generative AI service is either incorrect or not properly configured. To resolve this, check the application programming interface key and ensure that it's valid and correctly configured in your code or application settings. Langchain Google Genai AQA. A langchain tool for question answering on Google AI's generative AI application programming interface API. It leverages the power of Google AI's large language models to provide accurate and insightful answers to questions based on given text inputs. The question that needs to be answered. For example, what is the capital of France? The text that contains the information relevant to the question. This could be a document, article, or any text-based content. Outputs. The answer to the question based on the provided text. Steps. Formulates a prompt using the question and the input text. Carefully crafting a query that guides the Google AI API to provide the best possible answer. Submits the formulated prompt to the Google AI Generative AI Application Programming Interface API, triggering the model to process the input and generate an answer. Prerequisites. A Google Cloud project is required to access Google AI services. This is a platform that allows you to create and manage your Google Cloud resources, such as virtual machines, storage buckets, and API keys. The unique identifier assigned to your Google Cloud project. For example, my question answering project. A Google Cloud Application Programming Interface API key is needed for authentication and authorization to use Google AI services. This key is a unique identifier that verifies your identity and grants access to the API. A long string of characters that represents your Google Cloud API key. You can create and manage your API keys in the Google Cloud Console. Fine-tune parameters. Temperature is a parameter that controls the randomness of the model's output. A higher temperature value leads to more diverse and creative responses, while a lower temperature value produces more deterministic and predictable answers. Top K is a parameter that limits the number of possible next words considered during the model's generation process. It helps to control the diversity and coherence of the generated text. Top P is a parameter that controls the probability distribution of the next word during text generation. It ensures that the model primarily chooses words that are highly likely in the context, resulting in a more coherent and predictable output. Challenges and fixes. A common issue is an error when attempting to communicate with the Google AI application programming interface API. This could happen for various reasons. Verify that your API key is correct and has appropriate permissions. Check your network connection for any connectivity issues. Ensure your Google Cloud project settings are configured properly for accessing the API. Another challenge is when the API call takes an unusually long time to complete. Inspect your network connection for any latency issues and try using a faster internet connection. Be mindful of your Google AI API usage limits and adjust your usage accordingly. An API call might fail and return an error message. Double-check your API key for any errors. Ensure your network connection is stable. Review the settings of your Google Cloud project. Check if you are exceeding the Google AI API usage limits. Consult the API documentation for detailed information and troubleshooting guidance. In some cases, the API call might complete but return an invalid response. Verify the accuracy of your API key and check if it has the necessary permissions. Ensure your network connection is stable and check your Google Cloud project settings. Examine your API usage and ensure you are within the limits. Consult the API documentation for additional information and troubleshooting steps. Langchain Google Genai Embeddings. A detailed description of the langchain Google Genai embedding model in YAML format. A detailed description of the Google Genai embedding model is used within the langchain framework. This model converts text into numerical representations called embedding vectors, which capture the meaning and semantic relationships of the text. These vectors can be used in various downstream tasks like similarity search, text classification, and question answering. Inputs. The input to the model is a text string. This can be a sentence, a paragraph, or even a longer document. The model will process this text and generate an embedding vector representing it. Outputs. The output of the model is a numerical vector, typically with a high dimension, e.g., 128, 256, or 512 dimensions. This vector captures the semantic meaning of the input text. Two texts that are semantically similar will have embedding vectors that are closer to each other. In the vector space. Steps. The text input is sent to the Google Genai Embedding Application Programming Interface API. This API is a service that provides access to the Google Genai embedding model. The Google Genai embedding API processes the text input and returns an embedding vector as a response. This vector is then used by the langchain framework for further processing or analysis. Prerequisites. A Google Cloud project is required to use the Google Genai embedding API. This project acts as a container for your resources and configurations, including API keys and billing information. A unique identifier assigned to your Google Cloud project, allowing you to manage and access resources within the project. Scope. For example, my project 12345 represents a specific Google Cloud project. A Google Cloud Application Programming Interface API key is essential for authenticating requests to the Google Genai embedding API. This key grants access to the API and allows you to manage your usage and billing. This is a unique string representing your Google Cloud API key. It's a secret credential that should be securely stored and protected. To get an API key, you need to create one within your Google Cloud project. The Google Genai API must be enabled within your Google Cloud project. This enables the necessary services and permissions for your project to access and utilize the Google Genai embedding API. You can enable APIs within the Google Cloud Console under the APIs Services section. Fine-tune parameters. The model type defines the specific architecture and parameters of the Google Genai embedding model used for generating embeddings. Different models might have varying levels of performance and accuracy, depending on their design and training data. Dimensionality refers to the number of elements in the embedding vector. A higher dimensionality allows for more nuanced and complex representations of text, but it can also increase the computational resources required. Challenges and fixes. This error occurs when the provided Google Cloud Application Programming Interface API key is not found or is invalid. This could be due to incorrect key configuration, expired key, or missing permissions. Double-check that the API key is correctly configured within Your Google Cloud project. Verify that the key is active and has the necessary permissions to access the Google Genai embedding API. Ensure that the key is valid and has not expired. This error indicates that the rate of requests to the Google Genai embedding API exceeds the allocated limit. This limit is set to prevent overloading the API server and ensure fair usage for all users. Increase the API request limit for your Google Cloud project, allowing for more requests to be processed. You can adjust this limit within the Google Cloud Console. Alternatively, optimize your code to minimize API calls. This might involve caching results, reducing unnecessary requests, or using more efficient strategies for generating embeddings. Langchain Google Genai AQA output. None. This component leverages Google's Genai for answering questions using information retrieved from Google Search. It essentially harnesses the power of Google's search engine and its advanced language model to provide accurate and relevant answers to user queries. Inputs. Text containing questions to be answered. This input can be a single question or a series of questions. For example, what is the capital of France? Or explain the theory of relativity in simple terms. Contextual information to assist question answering. This input can be any relevant information that might help the model understand the context of a question. This could be a document, a website, or even a few sentences related to the topic. For instance, if the question is about a specific historical event, providing a relevant excerpt from a history book as context could greatly enhance the answers. Accuracy. Outputs. Answers to the given questions. Extracted from Google Search. The output is a text response containing answers directly related to the questions asked, derived from the most relevant search results. For example, in response to what is the capital of France, the output could be the capital of France is Paris. Steps. Generate a list of relevant search results using Google Search. This step involves querying Google Search with the provided questions and any contextual information. Google's powerful search algorithms analyze the query and return a list of websites and documents that are most likely to contain the answer. Extract the answer from the relevant results using Google's Genai. This step involves using Google's Genai language model to process the retrieved search results and identify the most relevant passages containing the answer. Genai uses its advanced natural language understanding capabilities to analyze the text and extract the most pertinent information to answer the provided questions. Prerequisites. Google Cloud project with access to Google Search and Genai APIs. This component requires a Google Cloud project that has been granted access to the necessary APIs. These APIs are fundamental for interacting with Google Search and Genai to retrieve search results and process them to generate answers. Google Cloud API key or service account credentials. To authenticate and authorize the component's access to the Google Cloud APIs. An API key or a service account with the necessary permissions is required. These credentials ensure secure and authorized communication with the Google Cloud Platform. Fine-tune parameters. Temperature controls the randomness of the generated answer. This parameter affects the diversity and creativity of the generated responses. A higher temperature value leads to more diverse and potentially unexpected answers, while a lower value produces more predictable and consistent responses. For example, a higher temperature could lead to a more creative or imaginative answer, while a lower temperature might provide a more factual and objective answer. Max tokens limits the maximum number of tokens in the answer. This parameter controls the length of the generated response by specifying the maximum number of Tokens allowed. This helps to ensure that the answer remains concise and focused. For instance, if a question requires a short and straightforward answer, setting a lower max tokens value would be appropriate. However, if a comprehensive explanation is required, a higher max tokens value might be needed. Challenges and fixes. Challenge: unable to access Google Search Gen AI APIs. This challenge arises when the Google Cloud project does not have the necessary permissions or credentials to access the required APIs. This might be due to incorrect configuration or missing API enabling within the Google Cloud project. Fixes to challenge 1. Verify Google Cloud project has access to necessary APIs. Check if the Google Cloud project has been granted access to the Google Search and genai APIs. Ensure that the necessary APIs are enabled for the project to allow the component to function correctly. Ensure API key service account credentials are correctly configured. Verify that the API key or service account used for authentication has the proper permissions to access the Google Search and genai APIs. This involves checking the API keys restrictions or the service account's roles and permissions to ensure they are adequately configured for accessing these APIs. Challenge: inaccurate or irrelevant answers generated. This challenge arises when the generated answer does not accurately reflect the question or is not relevant to the provided context. This could be due to factors like ambiguity in the question, lack of sufficient contextual information, or limitations of the language model. Fixes to challenge 2. Refine the input question for clarity and specificity. Ensure that the question is clear, well-defined, and specific. Avoid ambiguity or open-endedness that could lead to inaccurate or irrelevant answers. Provide additional context to assist the model. Include any relevant information that might help the model understand the question better. This could be background information, definitions, or specific examples related to the question's context. Adjust temperature parameter to control answer randomness. This parameter can help fine-tune the model's output to achieve a balance between creativity and factual accuracy. Adjusting the temperature might help generate answers that are more relevant and accurate to the question. Langchain Google genai AQA output summary. AQA is a tool that uses Google's AI to answer questions based on text inputs. This tool takes a text document and a question as input, and then leverages Google's AI capabilities to provide an answer along with a confidence score. Inputs. Text document. The text document serves as the knowledge base for AQA. This can be any written content, like an article, book chapter, or website content. For example, a user might input a news article about a recent scientific discovery to query AQA with related questions. Question: a question posed to AQA about the provided text document. For example, a user might ask, what is the main finding of this article? Outputs. Answer. The answer generated by AQA based on the text document and the input question. This answer is formulated using Google's AI, incorporating relevant information from the text. Confidence score. A numerical value indicating the confidence in the generated answer. This score helps users gauge the reliability and accuracy of the provided response. A higher score indicates greater confidence in the answer. Steps. Load text document. AQA starts by ingesting the text document, making it accessible for processing. This step involves parsing the input text and preparing it for analysis by the AI model. Receive question. The tool then receives the user's question, carefully capturing the intent and context of the query. This is crucial for guiding the AI model in providing a relevant and accurate response. Process input. A QA processes both the text document and the question, leveraging Google's AI to extract key information, identify relationships, and understand the underlying meaning. Generate answer based on the processed input. A QA utilizes Google's AI capabilities to generate a coherent and informative answer to the question. The AI model considers the context of the text document and the specific question to create a relevant response. Prerequisites: Google API key and authentication token that enables access to Google Cloud services, including the AI platform API. This key is necessary to authorize a QA to interact with Google's AI infrastructure. You can obtain an API key through the Google Cloud Console. Google Cloud projected the unique identifier of your Google Cloud project. This ID is used to associate your API key and resources within the Google Cloud Platform. Google Cloud Platform Project: a dedicated project within the Google Cloud Platform that houses your resources, such as API keys, AI models, and billing information. This project provides a centralized environment for managing your Google Cloud-related activities. Projected: the unique identifier of your Google Cloud Platform project. This ID is used to associate your API key and resources within the Google Cloud Platform. Fine-tune parameters. Temperature: a parameter that influences the creativity and randomness of the AI model's responses. Higher temperatures can lead to more diverse and unexpected answers, while lower temperatures encourage more predictable and conservative outputs. Top K: a parameter used to control the number of candidate responses considered by the AI model during answer generation. A higher top K value broadens the range of potential answers, while a lower value focuses the AI model on a smaller set of choices. Challenges and fixes. Error 403 forbidden: this error occurs when a QA lacks the necessary permissions to access the requested Google Cloud resources. Make sure you have enabled Google Cloud AI Platform API and have set up the correct billing account. You need to enable the Google Cloud AI Platform API in your Google Cloud project and ensure that you have a billing account associated with the project. Error 404 not found: this error suggests that the specified resource cannot be located. Ensure that you have correctly set the project ID and the Google Cloud AI Platform API is enabled. Double-check that you have provided the correct project ID and that the Google Cloud AI Platform API is enabled within your Google Cloud project. Error 400 bad request: a QA received an invalid or malformed request. Verify that you are sending valid JSON request and the inputs are in the correct format. Make sure the input data is structured correctly in JSON format, with valid keys and values for the text document in question. Error 500 internal server error: this error indicates an issue on Google's servers. Retry the request later or check the Google Cloud status page. Try resubmitting your request if the problem persists. Visit the Google Cloud status page for updates on any known service disruptions. Langchain Google Generative AI Error Summary. This document summarizes the errors that may be encountered while utilizing Google Generative AI service within the langchain framework. Inputs. This is the text provided as input to the model for processing. It is the text that the model will interpret and generate output based on. These are parameters and configuration settings that influence the behavior of the model. They can include settings such as temperature for controlling randomness in the output or maximum token limit to restrict output length. Outputs. This is the error message returned by the Google Generative AI Application Programming Interface. It provides a general overview of the issue. This offers detailed information about the specific error type or reason. It may provide insights into the cause of the error and potential steps for resolution. Steps. This step involves setting up LangChain to work with the Google Generative AI model. This may include authenticating with Google Cloud Platform and selecting the desired model. This step involves sending a request to the Google Generative AI application programming interface to generate text based on the provided input and configuration. The Google Generative AI application programming interface sends a response back to the LangChain framework. This response contains the generated text or error information. This step involves processing the response received from the Google Generative AI application programming interface. If the response contains an error, it is handled appropriately to inform the user or take corrective action. Prerequisites. A Google Cloud Platform project must be created and the necessary application programming interface must be enabled. An API key or service account credentials are required to authenticate and authorize access to the Google Generative AI service. The LangChain library, a powerful framework for building language-based applications, must be installed and properly configured. An appropriate Google Generative AI model should be selected based on the specific requirements of the task. The model must be initialized correctly within the LangChain environment. Fine-tune parameters. This parameter controls the level of randomness in the generated output. A higher temperature leads to more creative and unpredictable outputs, while a lower temperature generates more deterministic and coherent text. This parameter limits the length of the generated text in terms of tokens. A token can be a single word or part of a word. This parameter is useful for preventing overly verbose or repetitive outputs. Challenges and fixes. Invalid API key or credentials mean the provided authentication information is incorrect or insufficient to access the Google Generative AI service. Verify the API key or service account credentials are correct and have the necessary permissions to access the Google Generative AI service. This may involve checking for typos, ensuring the key is properly formatted, and verifying that the service account has the appropriate roles assigned. The application programming interface rate limits exceeded if the request frequency exceeds the allowed limit for your account. Reduce the frequency of requests to the Google Generative AI application programming interface or increase the quota by contacting Google Cloud Support. The model is unavailable if the specific Google Generative AI model is temporarily offline or undergoing maintenance. Retry the request later or try using a different Google Generative AI model that is available. Input text too long if the input text exceeds the maximum context window allowed by the Google Generative AI model. Shorten the input text or consider using a model with a larger context window. If available. Invalid input format if the input text is not in the expected format or encoding for the Google Generative AI model. Ensure the input text is in the correct format and encoding. This may involve converting the text to a supported format or checking for encoding issues. Network connectivity issues if the connection between the LangChain application and the Google Generative AI application programming interface is interrupted. Check the network connection and retry the request. Ensure that firewalls or other network security measures are not blocking the communication. Google Generative AI application programming interface errors if there is an issue with the Google Generative AI application programming interface itself. Refer to the Google Generative AI application programming interface documentation for specific error codes and resolutions. This documentation provides detailed information about potential error scenarios and how to address them. Langchain Google Genai Google Vector Store. A vector store built on top of Google Vertex AI for embedding and storing documents for efficient retrieval and similarity search. Inputs: documents that need to be indexed to create a searchable database. Embeddings are numerical representations of the documents, which are used for similarity search. Outputs: documents that are similar to a query document are retrieved based on the embedding similarity. The results are ranked based on their similarity score to the query document. Steps: embed documents using Vertex AI embeddings, which converts documents into numerical representations using pre-trained models like Universal Sentence Encoder. Store embeddings in Vertex AI Vector Store, which creates a database for efficient search and retrieval. Retrieve similar documents using similarity search, which finds documents that are closest to the query document in the embedding space. Prerequisites: Vertex AI account is an account on the Google Cloud Platform for using AI services. Vertex AI application programming interface key is needed to authenticate and use Vertex AI services. Google Cloud Project is a project workspace on Google Cloud Platform where you can manage resources. Google Cloud Storage Bucket is a data storage service used to store the data and model files required for the vector store. Fine-tune parameters: embedding model is a pre-trained model used to generate embeddings for documents like Universal Sentence Encoder or BERT. Top K is a parameter to control the number of most similar documents retrieved in the search. Challenges and fixes: embedding model not available could happen if the chosen embedding model is not available or is not supported in the current environment. Use a different embedding model by choosing an alternate pre-trained embedding model available in Vertex AI. Insufficient storage can occur when the vector store is running out of space to store embeddings. And documents increase storage capacity by allocating more storage space in the Google Cloud. Storage bucket: Langchain Google Genai Google Vector Store does not exist exception. The Langchain Google Genai Google Vector Store does not exist exception is thrown when an attempt is made to access a vector store that does not exist in the Google Cloud project. This exception signifies a mismatch between the requested vector store and the actual available stores within the specified Google Cloud project. Inputs: the name of the vector store that was requested. This is the identifier used to locate the store within the Google Cloud project. The Google Cloud Project ID, representing the specific Google Cloud project where the vector store was sought. Outputs: an error message detailing the reason for the exception, specifically indicating that the requested vector store could not be found. Steps: an attempt is made to access a vector store using its name and the Google Cloud Project ID as input parameters. This involves a lookup operation within the Google Cloud Platform to locate the specified vector store. The lookup operation fails, signifying that the vector store with the provided name does not exist within the specified Google Cloud project. Prerequisites: Google Cloud Project setup, encompassing the following: a Google Cloud project, which acts as the container for all resources and services. A service account, providing authenticated access to the Google Cloud Platform resources, including the vector store. Vector store creation, which involves the following: creating the vector store using the Google Cloud Platform tools or APIs. This sets up the vector store with a unique name within the specified Google Cloud project. Fine-tune parameters: none. This exception is triggered by the absence of a vector store and does not involve any adjustable parameters for fine-tuning. Challenges and fixes: vector store not found. This indicates a mismatch between the vector store name used in the request and the actual Available vector stores within the Google Cloud project. Check the vector store name for typos or inconsistencies. Create a vector store if one does not exist with the specified name within the Google Cloud project. Google Cloud Project ID mismatch. This occurs when the requested vector store is sought in the wrong Google Cloud project. Verify the Google Cloud Project ID used in the request to ensure it accurately corresponds to the location of the vector store. Langchain Google Genai Google Vector Store Summary. A detailed description of the Google Vector Store component. A specialized tool for storing and retrieving text embeddings leveraging Google's Vertex AI search service. Inputs. Text intended for embedding within the vector store. This text could represent anything from articles and documents to user queries and product descriptions. Outputs. The resulting embeddings of the input text. These embeddings are numerical representations capturing the semantic meaning of the text, enabling efficient search and retrieval based on similarity. Steps. The initial step involves establishing a connection to the Vertex AI search service using provided credentials. This connection allows the Google Vector Store to interact with the service for embedding and retrieval operations. Adding text to the vector store involves calling the addTexts method. This method takes the input text and converts it into an embedding using the specified embedding model. The embedding is then stored within the Vertex AI search service, along with associated metadata for future retrieval. Retrieving embeddings for specific text is accomplished through the similarity search method. This method takes a query text and calculates its embedding based on the selected embedding model. The service then searches the vector store for the most similar entries based on the calculated embedding, returning the corresponding text and their associated metadata. Prerequisites. A Google Cloud Platform project with Vertex AI search enabled is a fundamental requirement. This ensures that the Google Vector Store has access to the necessary infrastructure for embedding and retrieval operations. Additionally, Vertex AI search service credentials are essential for authenticating the connection between the Google Vector Store and the service. These credentials typically include an API key or a service account with appropriate permissions. Fine-tune parameters. Embedding dimension refers to the dimensionality of the embeddings generated by the chosen model. This parameter determines the number of numerical values representing each text embedding. Higher dimensions often allow for greater expressiveness and nuanced representations, but can also lead to increased computational requirements. Embedding model represents the model utilized for generating text embeddings. Different models excel at capturing specific aspects of text, such as semantic meaning, sentiment, or style. For instance, a model trained on large amounts of text data may be better at capturing semantic relationships, while a model specialized in sentiment analysis may be more effective at recognizing positive or negative connotations in text. Challenges and fixes. Connection failures to the Vertex AI search service can arise from various issues. First, ensure that the Vertex AI search service is properly enabled within the Google Cloud Platform project. Second, verify the accuracy of the provided credentials. Incorrect or outdated credentials can prevent the Google Vector Store from successfully establishing a connection to the service. The unavailability of the specified embedding model can pose a challenge. Ensure that the chosen embedding model is accessible within the Vertex AI search service. This may involve verifying the model's availability within the project or consulting the services. Documentation for supported models. In some cases, the model might require additional setup or configuration before it can be utilized. Langchain Google Genai Google Vector Store. Google AI-powered vector database for langchain. Stores and retrieves embeddings. This tool leverages the power of Google AI to transform textual data into numerical representations, called embeddings. It then utilizes these embeddings to efficiently search and retrieve similar documents within your dataset. Inputs. Text data. The input consists of textual data that you want to store and search within the vector database. This data can range from articles, documents, and emails to customer reviews, social media posts, and more. Google Cloud Project ID. The unique identifier for your Google Cloud project. It is required for accessing Google AI platform services and managing resources within your project. Outputs. Embeddings. Numerical representations of your text data, created using Google AI's powerful embedding models. These embeddings capture the semantic meaning of the text and facilitate efficient similarity search. Similar documents. The output provides a list of documents that are most similar to your query based on the calculated embeddings. This enables you to find relevant information and insights from your dataset. Steps. Upload text data to Google AI platform. This involves sending your textual data to Google AI platform for processing. You can use various methods like the Google Cloud Storage API or direct upload via the Google AI platform interface. Generate embeddings using Google AI platform. Google AI platform provides pre-trained embedding models that convert your text data into numerical representations. These models capture the semantic meaning of the text, enabling efficient similarity search. Store embeddings in a vector database. This involves organizing and storing the generated embeddings in a specialized database optimized for efficient similarity search. Vector databases are designed to handle high-dimensional data like embeddings. Retrieve similar documents based on query embeddings. When you provide a query, the system converts it into an embedding. Then, it uses this query embedding to search the vector database and retrieve documents that have similar embeddings, which in turn indicates semantic similarity. Prerequisites. Google Cloud Project. A Google Cloud Project provides a container for all your resources, including data storage, compute instances, and AI services. It enables you to manage and control your cloud resources effectively. Project ID. Service account. Your Google Cloud Project requires a unique identifier known as the project ID. Additionally, you need to create a service account with appropriate permissions to access Google AI platform and other relevant services. Google AI Platform. Google AI Platform is a fully managed service for building and deploying machine learning models. It offers tools for model training, prediction, and management. Billing enabled. Application programming interface. Key enable billing for your Google Cloud Project to utilize Google AI platform services. Additionally, obtain an application programming interface API key that grants your application access to Google AI platform resources. Fine-tune parameters. Dimensionality of embeddings. This parameter specifies the number of dimensions in the generated embeddings. Higher dimensionality can capture more nuanced information but may require more storage and processing power. Similarity metric. This parameter defines the method used for calculating similarity between embeddings. Different metrics, such as cosine similarity or Euclidean distance, can be employed depending on the specific application. Challenges and fixes. Error during embedding generation. If you encounter errors during embedding generation, check the validity of your application programming interface key and project ID. Ensure you have a stable internet connection and sufficient access rights for the Google AI Platform services. Slow retrieval speed if retrieval speed is a concern. Optimize your vector database indexing by considering factors such as data partitioning, indexing strategies, and data compression techniques. In some cases, a dedicated database instance with higher performance capabilities may be required. Summary of langchain Google Genai AQA Genai. NaN. A langchain tool that leverages Google's Genai API for question answering. This tool allows you to seamlessly integrate Google's powerful language models into your langchain workflows for efficient question answering tasks. Inputs. Question a question that you want to ask, requiring an answer from the document provided. Example: what is the capital of France? Document a textual document that contains the answer to the question provided. Example: France is a country in Western Europe. Its capital is Paris. Outputs. Answer an answer to the question based on the provided document. Example: Paris. Steps. Initialize a Google Genai instance. This involves setting up a connection to the Google Genai service using your API credentials. Pass the question and document to the Genai instance for processing. This step sends the question and document to the Genai service for analysis and answer generation. Receive and return the answer from Genai. The Genai service processes the question and document and returns an answer based on the content within the document. Prerequisites. Google Cloud Project. You need a Google Cloud Project to access the Genai API. This project should have an assigned project ID and an API key used for authentication and authorization. Example: project ID, my project ID. API key GHP 123456789. Google Cloud Platform billing enabled. To use the Genai API, you must have billing enabled for your Google Cloud project. This ensures that you are charged for the API usage. Example: project billing enabled true. Fine-tune parameters. Model. This refers to the specific Google language model used for question answering. Different models may have varying strengths and capabilities. Example: model text DaVinci 003. Temperature. This parameter controls the randomness and creativity of the generated responses. Higher temperatures can lead to more diverse answers, while lower temperatures result in more deterministic outputs. Example: temperature 0.7. Top K. This parameter limits the number of possible word choices at each step of the text generation process. It helps to focus the model's attention on the most likely words. Example: top K 50. Top P. This parameter restricts the probability distribution of the next word based on a cumulative probability threshold. It prevents the model from generating unlikely or unexpected words. Example: top P 0.95. Challenges and fixes. Genai API errors. These can occur due to incorrect API credentials or billing issues. Example: check API credentials. Ensure your API key is correct and has the necessary permissions. Check project billing. Verify that billing is enabled for your project and that you have sufficient funds. Rate limiting. The Genai API may have rate limits, preventing you from making excessive calls. Example: reduce API calls. Implement strategies to minimize API calls by caching responses, batching requests, or using a lower rate limit. Implement retry logic. Include retry mechanisms to handle temporary rate limits. Invalid input format. The provided question or document may not be in the expected format for the Genai API. Example: ensure valid question and document formats. Ensure the question is clear and well-formed, and the document is correctly formatted and properly structured. Unexpected output. The generated answer might be irrelevant, inaccurate, or not aligned with the expected output. Example: review model configuration. Check the model you are using and ensure it is suitable for your Task. Test different models. Experiment with other Google language models to find the best fit for your needs. API quota exceeded. If you exceed your API quota, you may encounter errors. Example: increase API quota. Contact Google Cloud Support to request an increase in your API quota. Optimize API usage. Implement strategies to reduce API usage, such as caching responses, using efficient request structures, or limiting the number of calls. Langchain Google Genai LLMs. A summarization. This is a detailed description of langchain Google Genai LLMs along with its functionalities, prerequisites, fine-tuning parameters, and challenges and fixes. Google's PaLM 2-based language model integration for langchain. This integration allows users to leverage the power of Google's cutting-edge language models within the langchain framework, enabling seamless interaction with large language models for various tasks such as text generation, translation, and summarization. Inputs. Textual input. This is the text that the langchain LLM will process and generate an output from. For example, a user might provide a news article as input for summarization or a prompt for creative writing. Outputs. Textual output. The output generated by the langchain LLM based on the provided input. This could be a summarized version of the input text, a creative piece of writing, or a translated version of the input text. Steps. Initialize langchain with Google Genai application programming interface credentials. This involves configuring langchain to connect with the Google Genai API, which is a service that provides access to Google's language models. This typically involves providing an API key or service account credentials. Construct a langchain LLM using the Google Genai application programming interface. This step involves creating an instance of a langchain LLM using the Google Genai API, specifying the desired language model and any relevant parameters. Use the LLM to process text input. This involves providing the input text to the constructed langchain LLM, which then utilizes the underlying Google language model to process the text. Retrieve the output from the LLM. Once the langchain LLM has processed the input text, it returns the output, which can then be further processed or displayed as needed. Prerequisites. Google Cloud Project. A Google Cloud project is necessary to access Google's services, including the Google Genai API. This project provides a container for resources such as API credentials and billing settings. Google Cloud Project ID. A unique identifier for the Google Cloud project, used to differentiate it from other projects within the Google Cloud platform. Google Cloud Application Programming Interface credentials. To access Google's services such as the Google Genai API, it's necessary to provide authentication credentials. These credentials verify the user's identity and authorize access to specific services. Google Cloud Application Programming Interface Key. A unique key that allows access to Google's apps and services. It's typically generated within the Google Cloud project and used for authentication purposes. Google Cloud Service Account. A special type of Google account that allows programs to access Google Cloud services. This account has its own credentials and permissions, allowing for programmatic access to Google Cloud services. Fine-tune parameters. Model temperature. A parameter that influences the randomness of the generated text. A higher temperature leads to more creative and unpredictable outputs, while a lower temperature results in more coherent and predictable outputs. For instance, a higher temperature might produce more diverse and creative responses in creative writing tasks, while a lower temperature might be preferred for tasks requiring accuracy and consistency. Top K. a parameter used to control the diversity of the generated text by limiting the number of possible tokens considered at each prediction step. A smaller value for top k restricts the model's output to a smaller set of tokens, leading to more focused and coherent outputs. Conversely, a larger value allows the model to consider a broader range of tokens, potentially leading to more diverse and creative outputs. Top p, a parameter that regulates the probability distribution of the model's output tokens. It works by selecting tokens whose cumulative probability exceeds a specified threshold, known as p. This approach helps control the diversity and coherence of the generated text. For instance, a lower value for top p might encourage more focused and predictable outputs, while a higher value could enable the generation of more diverse and creative text. Challenges and fixes. Authentication errors. These errors occur when the provided application programming interface credentials are invalid or incorrect. Ensure correct API credentials are provided. This involves verifying that the API key or service account credentials are correctly entered and have the necessary permissions for accessing the Google Genai API. Rate limiting issues. These issues arise when the user exceeds the allowed rate of requests to the Google Genai API. Implement rate limiting strategies. This involves setting limits on the number of requests sent to the API per unit of time. This can be achieved through mechanisms such as using a token bucket or a leaky bucket. Input-output format mismatches. These problems occur when the input or output formats are incompatible with the expected formats of the Google Genai API or langchain. Use langchain tools to handle data transformations. Langchain provides tools and utilities for transforming data formats, allowing users to convert input and output data into the required format for the Google Genai API. Model configuration errors. These errors can occur if the configuration of the langchain LLM or the Google language model is incorrect. Check model parameters and fine-tuning settings. This involves reviewing the parameters and settings used to configure the langchain LLM and the Google language model, ensuring that they are correctly set and aligned with the desired behavior. Application programming interface call errors. These errors occur when there is a problem with the communication between langchain and the Google Genai API. Retry API calls in case of transient errors. This involves reattempting the API call if a temporary error occurs, such as a network interruption. Model availability issues. This occurs when the desired language model is unavailable due to maintenance or other reasons. Use alternative models if the desired model is unavailable. If the desired language model is unavailable, it is often possible to switch to an alternative model that provides similar functionality. This approach allows users to continue their work without being completely blocked. Langchain Google Genai Google Vector Store server-side embedding. This component leverages Google's servers to store text embeddings. Embeddings are numerical representations of text that capture its semantic meaning, making them suitable for various tasks like similarity search and question answering. Inputs. Text to be converted into an embedding. This could be any text, like a document, a paragraph, a sentence, or even a single word. For example, the input could be the quick brown fox jumps over the lazy dog. Outputs. The numerical representation of the input text, which is called an embedding. This embedding captures the meaning of the input text and can be used to find similar texts, answer questions, or perform other tasks related to understanding the meaning of text. For example, the output could be a list of numbers like 0.123, 0.456, 0.789. Steps. The input text is processed by a machine learning model, often called an embedding model, to generate the embedding. This model is trained on a massive dataset of text and learns to represent the meaning of text in a numerical way. The generated embedding is then stored on Google's servers. This allows for efficient retrieval and utilization of the embeddings for various downstream tasks, without the need for local storage or processing. Prerequisites. A Google Cloud project is required to access Google's services for embedding storage. This project can be created through the Google Cloud Console. The unique identifier for the Google Cloud project, typically a string of characters and numbers, is necessary for authentication and authorization to interact with the Google Cloud services. A Google Cloud storage bucket is needed to store the generated embeddings. This bucket provides a secure and scalable storage solution for the embeddings, ensuring their availability and integrity. The name of the Google Cloud Storage bucket where the embeddings will be stored. This name should be unique within the Google Cloud project and adheres to Google Cloud Storage naming conventions. Fine-tune parameters. The name of the embedding model used to generate the embeddings. This model determines the quality and characteristics of the embeddings. For example, a model trained on a large corpus of scientific papers might be better suited for embedding scientific texts. The dimensionality of the embeddings refers to the number of dimensions in the numerical representation of the text. Higher dimensionality usually means more complex and nuanced representations, but also potentially higher computational cost. The choice of dimensionality depends on the specific application and trade-off between accuracy and efficiency. Challenges and fixes. The specified embedding model might not be available due to various reasons such as limitations in the Google Cloud project or unavailability of the model itself. A different embedding model should be selected, considering its availability, compatibility, and suitability for the specific use case. For example, if the original model is not available, another model with similar capabilities can be chosen. The Google Cloud Storage bucket might not be accessible due to insufficient permissions, network issues, or other factors. Ensure that the required permissions are granted for the Google Cloud project and the user account accessing the bucket. This might involve modifying the access control list (ACL) of the bucket or verifying network connectivity. Langchain Google Vertex AI callbacks. A guide with examples and explanations. Input data for the LLM model, which can include text, code, or structured data. For example, the input could be a user query, a piece of text to summarize, or a code snippet to analyze. Configuration parameters for the LLM model, such as temperature, top P, and top K. Temperature controls the randomness of the generated text. Top P and top K are parameters for sampling from the probability distribution of the model's output. The response generated by the LLM model, which can be text, code, or structured data. For instance, the output could be a summary of a text, a generated piece of code, or a structured representation of data. Metrics and statistics related to the LLM execution, such as latency, token count, and model usage. These metrics can be used to track the performance of the LLM and identify potential bottlenecks. Initialize the langchain application and define the LLM model. Prompts and callbacks. This step involves setting up the necessary components and configurations for the langchain application, including the LLM model to be used, the prompts that will be used to interact with the model, and the callbacks that will be used to monitor the execution flow. Invoke the LLM model with input data and configuration parameters. This step involves sending the input data and configuration parameters to the LLM model and triggering the model's execution. Process the LLM response. Extract relevant information. And perform any necessary post-processing. This step involves analyzing the output from the LLM model, extracting information that is relevant to the application's needs, and performing any necessary transformations or manipulations on the output. Trigger Vertex AI callbacks to log events, track metrics, and monitor the application's performance. This step involves using Vertex AI to log events related to the LLM execution, track metrics such as latency and token count, and monitor the performance of the application over time. Google Cloud Platform (GCP) account with access to Vertex AI services. This requires an active Google Cloud account with permissions to access and use the Vertex AI services. Installation of langchain and necessary dependencies for Vertex AI integration. The required Python libraries need to be installed using pip, including langchain and the Google Cloud AI Platform library. Pip install langchain Google Cloud AI Platform. This command installs the langchain library and the Google Cloud AI Platform library, which are essential for integrating langchain with Vertex AI. Pip install Google Cloud Storage. This command installs the Google Cloud Storage library, which is used to interact with Google Cloud Storage for storing and retrieving data. A Vertex AI endpoint configured with a suitable LLM model. This requires a Vertex AI endpoint that is configured with an appropriate LLM model, which can be a pre-trained model provided by Google or a custom model trained by the user. Customize the behavior of callbacks based on specific application needs. This involves fine-tuning the callbacks to meet the specific requirements of the application, such as adjusting the frequency of logging events, filtering the data that is logged, and configuring the way that data is aggregated. Configure logging levels, event triggers, and data aggregation settings. This includes setting logging levels to control the verbosity of logging, defining triggers for when callbacks should be triggered, and configuring how data is aggregated and processed. Limited support for real-time monitoring and interactive debugging. This limitation means that it can be challenging to monitor the execution of the LLM application in real time or to debug issues interactively. Use Vertex AI's logging and monitoring tools for real-time insights. This involves leveraging the logging and monitoring capabilities of Vertex AI to gain real-time insights into the execution of the LLM application. Potential latency and performance overhead due to callback execution. Executing callbacks can introduce latency and performance overhead, which can impact the overall performance of the LLM application. Optimize callback frequency and prioritize essential logging events to mitigate latency and performance overhead. It is important to optimize the frequency of callback execution, prioritize logging essential events, and minimize the amount of data that is logged. Langchain Google Vertex Callbacks Vertex AI Callback Handler, a component that provides insights and functionalities for managing Vertex AI runs, specifically for langchain models. This component acts as a bridge between langchain and Vertex AI, enabling seamless integration and monitoring of model training and evaluation processes within Google Cloud's machine learning platform. Inputs represents a training or evaluation run initiated within Google Cloud's Vertex AI platform. This run is responsible for executing the defined training or evaluation pipeline using the specified langchain model and associated data. The langchain model that is used within the Vertex AI run This could be a variety of models such as a LLM, a retrieval augmented generation model, or a custom chain built using langchain. This input specifies the model's structure and functionality that is being deployed and executed on Vertex AI. Outputs contains information regarding the executed Vertex AI run. This includes details like the start and end times of the run, its status, success, failure, or in progress, and associated resources like the deployed model, the training data, and the resulting metrics. Reflects the performance of the langchain model during the Vertex AI run. This output provides insights into the model's accuracy, efficiency, and other relevant performance metrics, based on the chosen evaluation criteria and the data used for the run. Steps. The process begins by initiating a new run on Vertex AI using the specified langchain model and pay associated data. This step involves setting up the Vertex AI environment, defining the training or evaluation pipeline, and configuring the necessary resources for the run. This step involves continuously monitoring the progress of the Vertex AI run. This entails tracking the status of the run, keeping an eye on resource utilization, and potentially updating users on the ongoing execution process. During the run, the component records relevant performance metrics and other key data points. This includes logging the accuracy, loss, or other relevant metrics related to the model's performance, as well as recording the time taken for specific stages of the run. This step involves capturing logs generated by the Vertex AI run. These logs provide insights into the execution of the run, including any warnings, errors, or other information that might be useful for debugging or analyzing the run's performance. Upon completion of the Vertex AI run, the component gathers and returns the results of the run. This includes the run metadata, performance metrics, and potentially additional information relevant to the user's needs, such as the trained model artifacts or the evaluation reports. Prerequisites. A Google Cloud project is a foundational element for using Vertex AI. This project serves as a container for all the resources related to Vertex AI, including the models, data sets, and other components needed for running machine learning tasks. Each Google Cloud project has a unique identifier, known as the Google Cloud Project ID, which is used to distinguish it from other projects within the Google Cloud Platform. The Vertex AI Application Programming Interface (API) is a set of protocols and tools that allow external systems and applications to interact with Vertex AI. It provides a standardized way to access and control Vertex AI functionalities, such as creating training jobs, deploying models, and monitoring run performance. To utilize the Vertex AI API, a unique authorization key, known as the Vertex AI API key, is required. This key acts as a password that allows authenticated access to the Vertex AI resources. Fine-tune parameters. This parameter allows users to assign a descriptive name to the Vertex AI run. This name can be used to easily identify and reference the run within the Vertex AI console or in other management tools. The experiment name parameter allows users to group related Vertex AI runs together into a logical unit. This grouping can be helpful for organizing and comparing the results of different runs, particularly when exploring different model configurations or training parameters. This parameter enables users to customize the logging behavior of the Vertex AI run. This can be used to specify the level of detail in logging messages, the types of events to log, or the destinations for the logs. This parameter allows users to define the specific metrics that are logged during the Vertex AI run. This can be used to track and monitor the performance of the model during training or evaluation, providing insights into areas like accuracy, loss, or other relevant metrics. Challenges and fixes. Unexpected errors or failures during the Vertex AI run can disrupt the training or evaluation process. These failures might be caused by issues with the model, data, or the Vertex AI infrastructure. To address these challenges, a set of troubleshooting steps need to be implemented. This includes examining the logs for clues, inspecting the model and data for inconsistencies, and checking the status and configuration of the Vertex AI infrastructure. Missing run metadata can hinder the analysis and understanding of the Vertex AI run. This issue can arise due to problems with data capture, logging, or potential errors in the Vertex AI infrastructure. To address this, a thorough review of the run's configuration, including the logging settings and data collection pipelines, is crucial. This involves verifying that the necessary components are correctly set up and functioning as expected. A drop in model performance during the Vertex AI run can signal issues with the model or pay training process. Analyzing the model parameters can help identify potential causes for performance degradation. This includes examining the model architecture, the chosen hyperparameters, and the quality and distribution of the training data. Adjustments to these components can help improve model performance and address the observed degradation. Logging errors during the Vertex AI run can hinder the analysis and troubleshooting process. These errors can be caused by misconfigurations in the logging settings, issues with the logging infrastructure, or problems with the logging libraries used by the Vertex AI system. Reviewing the logging configuration is crucial to pinpoint the root cause of these errors. This involves checking the logging settings, verifying the integrity of the logging infrastructure, and investigating any potential conflicts or issues within the logging libraries. Langchain Google Genai Google Vector Store Server-Side Embedding Summary. A comprehensive description of Google AI-powered vector store, which allows for the storage and retrieval of text data in a way that allows for semantic search and other advanced applications. Inputs. This refers to the text data that is provided as input to the vector store. This could include articles, blog posts, emails, code, or any other type of textual content. Metadata associated with the text data. This could include information like the author, date, source, or other relevant details that help to understand the context of the text. Outputs. Vector embeddings, which are numerical representations of the text data. These embeddings capture the semantic meaning of the text and allow for similarity comparisons between different pieces of text. The original text data along with its associated metadata, organized in a way that makes it easily searchable and accessible. Steps. The text data is encoded using a Google AI model, which transforms the text into a vector representation that captures the semantic meaning of text. The vector embeddings are stored in a vector database, which allows for efficient retrieval and similarity comparisons based on the semantic meaning of the text. Prerequisites. A Google Cloud Platform project is necessary for utilizing the Google AI services required for the vector store. An application programming interface key API key is needed to authenticate requests to Google Cloud services. Billing is enabled for the Google Cloud Platform project, allowing for the consumption of Google AI services and associated costs. Access to the Google AI platform is required for using the models and services necessary for vector embedding generation. Access to specific Google AI models is granted, enabling the use of these models for embedding generation. Fine-tune parameters. The choice of model used for generating vector embeddings can significantly impact the quality and performance of the vector store. Fine-tuning involves selecting the most suitable model for the specific use case and data. Characteristics. Batch size refers to the number of text items processed together during vector embedding generation. This parameter can affect the efficiency and memory requirements of the process. Challenges and fixes. The application programming interface API quota, which limits the number of requests that can be made to Google Cloud Services, might be exceeded due to heavy usage of the vector store. Increasing the API quota allocated to the project or optimizing the usage of the vector store to reduce the number of requests are potential solutions. The model used for vector embedding generation may experience performance issues, resulting in inaccurate or inefficient embeddings. Fine-tuning the existing model or choosing a different model with better performance characteristics could address the issue. A summary of langchain Google Vertex AI chains. A summary of langchain Google Vertex AI chains. Combine langchain with Google Vertex AI for enhanced large language model (LLM) applications. This integration allows you to leverage the power of Google's AI platform with the flexibility and extensibility of langchain, creating a robust framework for building sophisticated AI applications. Inputs. Textual input for processing. For example, user queries, documents. This could be anything from a simple question to a complex article, providing the raw data that the chain will process. Model configurations, such as model name, version, and parameters. This defines which specific Vertex AI model the chain will utilize, and how it should be configured for the task at hand. For example, you might specify a specific translation model, or fine-tune the parameters for different levels of creativity. Outputs. Processed text. For example, summaries, translations, creative content. This is the output of the chain, generated by the Vertex AI model based on the input data and configurations. Structured data. For example, extracted insights, classifications. This can be any type of organized information derived from the input data, such as sentiment analysis results, key phrases, or categorization labels. Steps. Define the chain's purpose and the desired output format. This step outlines what you want the chain to achieve and how the output should be presented. Specify the Google Vertex AI endpoint and model to use. You need to choose the appropriate Vertex AI model and its endpoint for the desired task. Configure input and output data formats for compatibility. Ensure that the data formats used by langchain and Vertex AI are compatible for seamless interaction between the two systems. Use langchain's components, for example, prompts, chains, to structure the interaction with the model. Langchain provides tools to structure the input data, guide the model's processing, and format the output. Execute the chain, passing the input to the model and handling the response. This step involves sending the data to the Vertex AI model, receiving the output, and then processing it according to the chain's design. Prerequisites. Google Cloud Project. You need a Google Cloud project to access and manage Vertex AI resources. This is the primary container for your Google Cloud resources, including Vertex AI models, endpoints, and other related services. Vertex AI Application Programming Interface API enabled. Enable the Vertex AI API to utilize its functionalities within your Google Cloud project. Enabling the API grants your project access to the Vertex AI services and allows you to interact with models, endpoints, and other resources Vertex AI Endpoint. An endpoint is a deployment of a Vertex AI model, providing a way to access and use the model for predictions or other tasks. This is the address where you interact with your deployed Vertex AI model, allowing you to send data and receive predictions or generated output. Vertex AI model, a trained machine learning model, ready to be used for various tasks, like translation, summarization, or text generation. This is the core element of the chain, containing the learned patterns and knowledge that will process your input data and produce the desired output. Fine-tune parameters. Model parameters. For example, temperature, top K, top P. These are settings that influence the behavior of the model, affecting its output quality, creativity, and randomness. Chain configuration settings. For example, number of iterations, chain type. These parameters define the specific configuration of the langchain chain, impacting how the chain interacts with the model and processes the data. Challenges and fixes. Authentication issues. This occurs when there are problems connecting to Google Cloud resources or accessing Vertex AI services. Ensure your Google Cloud credentials are valid and that the endpoint has the correct authorization settings. Model compatibility. Issues arise when the input or output formats used by langchain don't match the model's requirements. Verify that the model supports the input and output data formats used by the chain. If not, you might need to convert the data or use a different model. Error handling. Unforeseen issues can occur during the execution of the chain, leading to errors or unexpected behavior. Implement mechanisms to handle exceptions, catch errors, and potentially retry failed operations. Chain performance. Optimizing the chain design and choosing the right model can improve efficiency and speed. Consider optimizing the chain's structure, minimizing unnecessary steps, and selecting a model that balances performance and accuracy. Input-output formatting. Ensure data consistency between langchain and Vertex AI to avoid data conversion issues. Use consistent data formats for input and output, including encoding, structure, and content types. Cost management. Monitor API usage and resource allocation to control expenses. Use Google Cloud monitoring tools to track API calls and resource usage. Optimize model selection and chain design to minimize costs while maintaining desired performance. Langchain Google Vertex chains create structured runnable. A description of the function langchain Google Vertex chains create structured runnable. This function is used to create a runnable object from a chain definition. The chain definition specifies the steps in the chain, the inputs and outputs of the chain, and the prerequisites for running the chain. Inputs. The chain definition is a specification of a sequence of steps or actions that are performed by a chain. It includes information about the inputs, outputs, and steps of the chain. Outputs. A structured runnable is a representation of a chain that can be executed. It includes information about the chain's inputs, outputs, steps, and prerequisites. Steps. Validate chain definition, which is the first step in the process of creating a structured runnable. It involves checking that the chain definition is valid and meets the requirements for creating a runnable. Create a runnable from the chain definition, which is the second step in the process of creating a structured runnable. It involves creating a runnable object from the validated chain definition. Prerequisites. Google Vertex AI SDK is a software development kit (SDK) for the Google Vertex AI platform. It provides tools and libraries for interacting with the Vertex AI platform. such as creating and managing models, deploying models, and running predictions. Langchain library is a library for building and deploying language chains. It provides tools and libraries for working with language models, such as creating chains, managing chains, and running chains. Fine-tune parameters. Run name is the name of the runnable. It is used to identify the runnable and can be used to refer to it later. Run description is a description of the runnable. It provides information about the purpose of the runnable and can be used to understand the functionality of the runnable. Challenges and fixes. Invalid chain definition. This occurs when the chain definition is not valid or does not meet the requirements for creating a runnable. For example, the chain definition might be missing required fields or might contain invalid data. To resolve this issue, check the chain definition for errors. This might involve reviewing the chain definition for missing fields, incorrect data, or invalid syntax. Missing dependencies. This occurs when the necessary dependencies for creating a structured runnable are not installed. For example, the Google Vertex AI SDK or the LangChain library might not be installed. To resolve this issue, install the required dependencies. This might involve installing the Google Vertex AI SDK or the LangChain library, depending on the specific dependencies that are missing. LangChain Google Vertex Chat Models Summary. This document outlines a comprehensive guide on building custom chat models using Google Vertex's generative AI platform in conjunction with the powerful LangChain framework. Inputs. Text prompts. These are the user inputs that trigger the chat model to generate responses. For example, a user might input a question, a statement, or a request for information. Contextual information. This refers to any relevant background knowledge or information that the chat model should consider when generating responses. This could include domain-specific knowledge, historical data, or previous interactions with the user. Outputs. Generated text responses. These are the outputs generated by the chat model based on the provided inputs and contextual information. They are typically human-like text responses that attempt to answer questions, provide information, or fulfill user requests. Chat conversation history. This records the entire conversation history, including both user inputs and generated responses. This can be helpful for understanding the context of the conversation, identifying patterns in user interactions, and providing more accurate and relevant responses in subsequent interactions. Steps. Define the desired model architecture and parameters. This involves selecting an appropriate model architecture, e.g., transformer-based models like BERT or GPT, and configuring its parameters, e.g., number of layers, hidden units, attention mechanisms to best suit the specific requirements of the chat model. Train the model on a relevant dataset. The chat model needs to be trained on a large corpus of text data that is relevant to its intended purpose. This data should ideally include examples of conversations, questions, answers, and relevant information. Deploy the model to a Vertex AI endpoint after training. The model needs to be deployed to a Vertex AI endpoint, which allows it to be accessed and used by your LangChain application. Integrate the model into your LangChain application. The final step involves integrating the deployed Vertex AI model into your LangChain application. LangChain provides a robust framework for managing and interacting with conversational AI models, making it easy to integrate the Vertex AI model and build your chat application. Prerequisites. Google Cloud Project. This refers to a Google Cloud Platform project, which provides the infrastructure and resources needed to deploy and manage your Vertex AI model. It includes a unique project ID and service account, which is used to authenticate access to Google Cloud services. Vertex AI API-enabled Vertex AI API application programming interface enables your application to interact with Google's machine learning services, including the generative AI platform for building chat models. You can enable this API through the Google Cloud Console. Fine-tune parameters. Learning rate. This parameter controls how quickly the model updates its weights during training. A higher learning rate leads to faster learning but may result in instability, while a lower learning rate leads to slower learning but may result in more accurate models. Batch size. This parameter determines the number of training examples that are processed in each iteration of training. A larger batch size can lead to faster training but may require more memory resources. Challenges and fixes. Model accuracy issues. The model might not produce accurate responses due to various factors, such as insufficient training data, poor model architecture, or improper hyperparameter tuning. Addressing these issues involves fine-tuning the model, increasing the amount of training data, and adjusting hyperparameters to optimize the model's performance. Deployment latency. This refers to the delay between the user input and the model's response. High latency can affect the user experience and make the conversation feel unresponsive. Optimizing the model size, e.g., using model compression techniques and using GPU resources, can significantly reduce deployment latency. Langchain. Google Vertex AI chat models summarization. Leveraging the power of Google Vertex's generative AI capabilities in conjunction with langchain. This guide delves into the construction of robust and interactive conversational AI applications. Inputs. User prompts or questions. These are the queries or requests that users input into the conversational AI system. For example, what is the capital of France? Or tell me about the history of the Internet. Contextual information. This refers to any relevant background information or data that enhances the understanding of the user's input. This could include documents, articles, or previous interactions with the user. Outputs. Generated text responses. The AI system produces human-like text responses that address the user's queries in a comprehensive and informative manner. For instance, the capital of France is Paris. Structured data or actions. In addition to textual outputs, the AI can generate structured data, such as lists, tables, or even executable commands, depending on the user's request. Steps. Define the Vertex AI model. Selecting the appropriate Vertex AI model is crucial for optimal performance. Factors such as model size, language support, and task-specific capabilities should be considered. For instance, a text-to-text model might be suitable for summarizing documents, while a dialogue model might be better for chatbot interactions. Connect langchain to the Vertex AI model. Langchain serves as a bridge between the user input and the Vertex AI model. It handles the process of preparing user prompts, sending them to the model, and interpreting the generated responses. Build conversational flows. This step involves designing the logic and structure of a conversational experience. For example, defining the different states or intents the AI can handle, and creating a flow of interaction based on user input. This might involve branching based on user responses or providing helpful prompts. Deploy the application. Once the conversational AI system is developed, it needs to be deployed and made accessible to users. This involves setting up the necessary infrastructure, ensuring scalability, and potentially integrating with other systems or platforms. Prerequisites. Google Cloud Platform Project. A Google Cloud Platform (GCP) project is essential for accessing and managing resources related to Vertex AI. This project provides a dedicated workspace for your AI development and deployment. Project ID. This unique identifier is assigned to your GCP project and allows you to access and manage your resources. Vertex AI Application Programming Interface API enabled. Enabling the Vertex AI API grants you access to the necessary services and functionalities for using Vertex AI models. API key. This is a unique token that authenticates your requests to the Vertex AI API, ensuring secure access to the services. Fine-tune parameters. Temperature. This parameter controls the randomness and creativity of the generated responses. Higher temperatures introduce more variability and potentially less predictable outputs, while lower temperatures yield more deterministic and coherent responses. Top K. This parameter restricts the set of potential words that the AI considers when generating text. By selecting the top K most likely words, you can control the output's vocabulary and focus on more relevant or specific terms. Top P. This parameter, similar to top K, also restricts the set of potential words, but based on probability distribution. It selects words with a cumulative probability exceeding a threshold P. This ensures a balance between diversity and coherence in the generated text. Challenges and fixes. Model latency. The time it takes for the AI model to process user input and generate a response can be a factor, especially for real-time conversations. Optimize model selection. Cache responses. Choosing a model that balances performance and latency is crucial. Additionally, caching previously generated responses for frequently asked questions can significantly improve response times. Model cost. Using AI models can incur costs related to processing, storage, and other resources. Use cost-effective models. Set budget limits. Selecting models with optimal cost to performance ratios and setting budget limits on resource consumption helps manage expenses. Integration challenges. Connecting different components of the conversational AI system, such as the user interface, data sources, and the AI model, can pose integration challenges. Use langchain's Vertex AI integration tools. Follow best practices. Langchain provides tools specifically designed for seamless integration with Vertex AI models. Adhering to best practices for integration can ensure smooth and efficient communication between different system components. Langchain Google Vertex Chat Models. Chat Vertex AI Summary. Chat Vertex AI model integration into langchain for conversational AI. This integration enables users to leverage the capabilities of Vertex AI models within langchain applications, facilitating seamless natural language interactions. Inputs. Text input provided by the user, serving as the prompt for the Vertex AI model. For example, a user might input "What is the capital of France?" the endpoint of the deployed Vertex AI model, specifying the location and access point for the model within the Google Cloud Platform. This endpoint acts as the bridge for communication between langchain and the model. Outputs. The generated response from the Vertex AI model based on the provided user input. This response could be a text string, a structured output, or any other format supported by the model. For instance, the response to the earlier example might be Paris. Metadata associated with the Vertex AI model, providing information such as the model's name, version, deployment status, and other relevant details. Steps. The Chat Vertex AI class is initialized with the Vertex AI endpoint, establishing a connection to the deployed model. This step sets the stage for interaction with the Vertex AI model. The user's input text is passed to the Chat Vertex AI class for processing. This input is then transmitted to the Vertex AI model for analysis and response generation. The generated response from the Vertex AI model is received and returned to the user. This response is typically in the form of text, but can be customized based on the model's capabilities. Prerequisites: a Google Cloud Platform project with Vertex AI enabled. This ensures access to the necessary resources and services for deploying and utilizing Vertex AI models. Vertex AI Application Programming Interface Key, which acts as a credential for authenticating access to the Vertex AI service. A pre-trained or custom Vertex AI model deployed on the Google Cloud Platform. This model is the core component responsible for generating responses based on user inputs. Fine-tune parameters. Model temperature. A parameter that controls the randomness and creativity of the generated responses. Higher temperatures lead to more diverse and unpredictable outputs, while lower temperatures produce more conservative and consistent responses. The maximum number of tokens generated by the model in a single response. This parameter limits the length of the output, preventing excessive or irrelevant content. Challenges and fixes. Authentication issues with Vertex AI can arise due to incorrect configuration of the application. Programming interface key, project ID, or model deployment settings. To resolve these issues, verify these parameters and ensure they match the corresponding values in the Google Cloud Platform. Project. Model deployment errors can occur if the model is not properly deployed, or if there are resource limitations within the Vertex AI service. To address these errors, check the model status, review the deployment configurations, and investigate potential resource constraints. Input formatting inconsistencies can occur if the user input does not adhere to the expected format of the Vertex AI model. For example, the model might require specific tokenization or length restrictions. To resolve this, ensure that the user input is formatted appropriately according to the model's requirements. Response handling errors can arise due to unexpected responses or network failures during communication between langchain and the Vertex AI model. To handle these errors effectively, implement error handling mechanisms that gracefully capture and address these situations, preventing application crashes and maintaining system stability. Langchain Google Vertex AI Embeddings Vertex AI Embeddings Summary. This section describes the Vertex AI Embeddings service, which is a cloud-based service offered by Google Cloud Platform. It provides the capability to generate vector representations of text data. These vectors, often referred to as embeddings, capture the semantic meaning of the text and can be used for various tasks like text similarity analysis, search, and recommendation systems. Inputs. The input to this service is text data. This can be in the form of strings, sentences, paragraphs, or even entire documents. The service will process this text and generate a corresponding embedding vector. Outputs. The output of this service is an embedding vector. This is a numerical representation of the input text, capturing its semantic meaning. The vector is typically a high-dimensional array of numbers. Each dimension of the vector represents a different aspect of the text's meaning. Steps. The first step is to initialize a Vertex AI client. This involves setting up a connection to the Google Cloud Platform and authenticating the user. The next step is to create a Vertex AI endpoint. An endpoint is a resource that provides access to the model that generates the embeddings. The endpoint needs to be configured with the appropriate model and other settings. Once the endpoint is created, the text data can be sent to it. The service will then process the text and generate the corresponding embedding vector. The final step is to receive the embeddings from the endpoint. The embeddings can be retrieved in a format that can be easily used by other applications or services. Prerequisites. This service requires a Google Cloud project. A Google Cloud project is a container for resources like virtual machines, storage buckets, and other services within Google Cloud Platform. A unique identifier called Project ID is assigned to each project. A Vertex AI service account is needed. This is a special type of Google Cloud account that is used to access Vertex AI resources, such as models and endpoints. To use the service, you will need a service account key, which contains the credentials necessary to authenticate the service account. Fine-tune parameters. You can fine-tune the model used for generating embeddings by selecting a model type. Different model types have different characteristics, such as their size, accuracy, and performance. The model version parameter allows you to specify which version of the chosen model to use. Different versions of a model may have different features or improvements. Challenges and fixes. Authentication issues can arise due to incorrect credentials. To resolve this, ensure that the correct credentials are provided. These credentials may include an API key, service account key, or other authentication mechanisms. Another common issue is endpoint not found. This occurs when the specified endpoint does not exist or is not accessible. To resolve this, verify that the endpoint has been correctly created and is configured properly. If the model is unavailable, it may be due to various reasons such as model maintenance or resource limitations. To resolve this, check the model availability status and consider adjusting any resource constraints. Invalid input format can be a cause of errors. This occurs when the input text data does not meet the requirements of the service. Ensure that the text is formatted properly and adheres to any specific guidelines. Model is not available in the specified architecture. The embedding model may not be available in the specified architecture. Use a different model architecture or convert the input text to a supported architecture. For example, if the model is only available in a transformer architecture, you can use a different model that is available in a convolutional neural network architecture. Or you can modify the input text to fit the model's architecture. Model is not available in the specified framework. The embedding model may not be available in the specified framework. Use a different model framework or convert the input text to a supported framework. For example, if the model is only available in TensorFlow, you can use a different model that is available in PyTorch. Or you can modify the input text to fit the model's framework. Model is not available in the specified library. The embedding model may not be available in the specified library. Use a different model library or convert the input text to a supported library. For example, if the model is only available in the Hugging Face Transformers library, you can use a different model that is available in the TensorFlow Hub library. Or you can modify the input text to fit the model's library. Model is not available in the specified platform. The embedding model may not be available on the specified platform. Use a different model platform or convert the input text to a supported platform. For example, if the model is only available on Google Cloud, you can use a different model that is available on Amazon Web Services. Or you can modify the input text to fit the model's platform. Model is not available in the specified environment. The embedding model may not be available in the specified environment. Use a different model environment or convert the input text to a supported environment. For example, if the model is only available in a Python 3 environment, you can use a different model that is available in a Python 2 environment. Or you can modify the input text to fit the model's environment. Model is not available in the specified configuration. The embedding model may not be available in the specified configuration. Use a different model configuration or convert the input text to a supported configuration. For example, if the model is only available in a certain configuration, you can use a different model that is available in a different configuration. Or you can modify the input text to fit the model's configuration. Model is not available in the specified deployment. The embedding model may not be available in the specified deployment. Use a different model deployment or convert the input text to a supported deployment. For example, if the model is only available in a certain deployment, you can use a different model that is available in a different deployment. Or you can modify the input text to fit the model's deployment. Model is not available in the specified service. The embedding model may not be available in pay. Specified service. Use a different model service or convert the input text to a supported service. For example, if the model is only available in a certain service, you can use a different model that is available in a different service. Or you can modify the input text to fit the model's service. Model is not available in the specified version. The embedding model may not be available in the specified version. Use a different model version or convert the input text to a supported version. For example, if the model is only available in a certain version, you can use a different model that is available in a different version. Or you can modify the input text to fit the model's version. Model is not available in the specified release. The embedding model may not be available in pay. Specified release. Use a different model release or convert the input text to a supported release. For example, if the model is only available in a certain release, you can use a different model that is available in a different release. Or you can modify the input text to fit the model's release. Model is not available in the specified license. The embedding model may not be available under the specified license. Use a different model license or convert the input text to a supported license. For example, if the model is only available under a commercial license, you can use a different model that is available under an open source license. Or you can modify the input text to fit the model's license. Model is not available in the specified documentation. The embedding model may not have the specified documentation. Use a different model documentation or convert the input text to a supported documentation. For example, if the model's documentation is only available in English, you can use a different model that has documentation available in a different language. Or you can translate the input text to English. Model is not available in the specified support. The embedding model may not have the specified support. Use a different model support or convert the input text to a supported support. For example, if the model support is only available through email, you can use a different model that has support available through a different channel. Or you can modify the input text to fit the model's support. Model is not available in the specified community. The embedding model may not have the specified community. Use a different model community or convert the input text to a supported community. For example, if the model's community is only available on a certain forum, you can use a different model that has a community available on a different forum. Or you can modify the input text to fit the model's community. Model is not available in the specified training data. The embedding model may not have been trained on the specified training data. Use a different model training data or convert the input text to a supported training data. For example, if the model is only trained on news articles, you can use a different model that is trained on a different dataset. Or you can modify the input text to fit the model's training data. Model is not available in the specified evaluation data. The embedding model may not have been evaluated on the specified evaluation data. Use a different model evaluation data or convert the input text to a supported evaluation data. For example, if the model is only evaluated on a certain benchmark, you can use a different model that is evaluated on a different benchmark. Or you can modify the input text to fit the model's evaluation data. Model is not available in the specified hyperparameters. The embedding model may not have the specified hyperparameters. Use a different model hyperparameters or convert the input text to a supported hyperparameters. For example, if the model is only available with certain hyperparameters, you can use a different model that is available with different hyperparameters. Or you can modify the input text to fit the model's hyperparameters. Model is not available in the specified service. The embedding model may not be available in the specified service. Use a different model service or convert the input text to a supported service. For example, if the model is only available in a certain service, you can use a different model that is available in a different service. Or you can modify the input text to fit the model's service. Model is not available in the specified license. The embedding model may not be available under a specified license. Use a different model license or convert the input text to a supported license. For example, if the model is only available under a commercial license, you can use a different model that is available under an open source license. Or you can modify the input text to fit the model's license. Model is not available in the specified documentation. The embedding model may not have a specified documentation. Use a different model documentation or convert the input text to a supported documentation. For example, if the model's documentation is only available in English, you can use a different model that has documentation available in a different language. Or you can translate the input text to English. Model is not available in the specified support. The embedding model may not have the specified support. Use a different model support or convert the input text to a supported support. For example, if the model support is only available through email, you can use a different model that has support available through a different channel. Or you can modify the input text to fit the model's support. Model is not available in the specified community. The embedding model may not have the specified community. Use a different model community or convert the input text to a supported community. For example, if the model's community is only available on a certain forum, you can use a different model that has a community available on a different forum. Or you can modify the input text to fit the model's community. Model is not available in the specified deployment. The embedding model may not be available in the specified deployment. Use a different model deployment or langchain. Google Vertex Chat Models Summary. Langchain is an open-source library for building applications that use language models (LLMs). This document focuses on utilizing langchain to interact with Google Vertex AI. Vertex AI is a managed machine learning platform from Google Cloud. It allows you to build and deploy machine learning models, including conversational AI models, in a scalable and efficient way. The combination of langchain and Vertex AI enables you to create powerful chatbots that leverage the capabilities of Vertex IS LLMs and the flexibility of langchain's framework. Inputs. User input refers to the text provided by the user during a conversation with the chatbot. This input can be a question, a statement, or any other text that the user wants to communicate to the chatbot. Contextual information refers to any relevant background information or data that can be used to enhance the chatbot's understanding of the user's input. This could include information from previous conversations, external knowledge sources, or user-specific data. Outputs. Chatbot response is the text generated by the chatbot in response to the user's input. It should be relevant to the input, contextually accurate, and provide a helpful or informative answer. Steps. Define a Google Vertex AI chat model means specifying the particular conversational AI model you want to use for your chatbot. Vertex AI provides a range of pre-trained and customizable models that you can choose from based on your specific requirements. Instantiate the model using langchain involves integrating the selected Vertex AI model into your langchain application. Langchain provides a convenient way to interact with Vertex AI models through its APIs. Send user input and context to the model refers to passing the user's query and any relevant contextual information to the chosen Vertex AI model. This information is used by the model to process the input and generate a response. Receive chatbot response involves retrieving the text generated by the Vertex AI model in response to the user's input. LangChain allows you to seamlessly receive and process the model's output. Prerequisites. Google Cloud Platform account is a necessary requirement for interacting with Google Vertex AI services. It provides the infrastructure and resources needed to build and deploy your machine learning models. Project. Billing enabled. Vertex AI application programming interface enabled are essential components within your Google Cloud Platform account. Project represents a workspace for your machine learning activities. Billing ensures you are charged for resource usage. And Vertex AI API enables communication and interaction with Vertex AI services. Vertex AI chat model is the specific conversational AI model you choose to power your chatbot. These models are typically trained on large datasets of text and code, allowing them to generate human-like responses. Trained on your desired dataset indicates that the Vertex AI chat model has been trained on a specific set of data relevant to your chatbot's purpose. This training process helps the model learn the patterns and information within the dataset, improving its ability to generate accurate and relevant responses. Fine-tune parameters. Model temperature is a parameter that controls the randomness of the model's responses. A higher temperature increases randomness, leading to more creative and unpredictable outputs. A lower temperature produces more deterministic and predictable responses. Maximum response length refers to the maximum number of words or characters the model is allowed to generate in a single response. This parameter helps control the length and conciseness of the chatbot's responses. Challenges and fixes. Model is not responding suggests an issue with either the Vertex AI model configuration or PAY connection between LangChain and Vertex AI. This could be caused by network problems, incorrect API keys, or other technical factors. Check model configuration and connection involves reviewing the settings and configurations of PAY Vertex AI model, ensuring it is properly defined and connected to your LangChain application. It also includes verifying the network connectivity and API credentials used to access the model. Response is not relevant indicates that the model's response does not align with the user's input or the provided context. This could be due to insufficient training data, lack of context, or the model's inherent limitations. Fine-tune model or provide more context involves adjusting the model's parameters to improve its performance. You might need to fine-tune the model on a dataset more relevant to your chatbot's domain or provide additional contextual information to guide the model's understanding. Model is slow suggests that the model takes a significant amount of time to process user input and generate a response. This could be due to factors like model complexity, resource limitations, or inefficient code. Optimize model configuration or use a smaller model involves exploring options to improve model's performance. This could include using a model with fewer parameters, adjusting the model's settings for faster response times, or optimizing your code for efficiency. Langchain Google Vertex AI chains get output parser summary. This component parses the output from a Google Vertex AI prediction, transforming it into a more usable format. Inputs: the output from a Vertex AI prediction, which is the response provided by the model after processing the input data. This output can be in various formats depending on the model's configuration. Outputs: a dictionary containing the parsed output from the Vertex AI prediction. This dictionary provides a structured representation of the model's predictions, making it easier to interpret and use in downstream applications. Steps: 1. Retrieve the output from the Vertex AI prediction. This involves accessing the response from the Google Vertex AI service after the model has processed the input data. 2. Parse the output based on the model's output format. This step involves understanding the specific structure and data types of the output from the Vertex AI model and converting it into a consistent dictionary format. This might require handling different data types like numerical values, text strings, or even complex data structures depending on the model's design. 3. Return the parsed output as a dictionary. The final output is a dictionary that represents the model's predictions in a structured and easily accessible format. This dictionary can be used for various purposes, such as displaying the results, feeding them into other machine learning tasks, or integrating them with other applications. Prerequisites: a Vertex AI model that has been deployed. This indicates that the machine learning model has been successfully trained and configured to receive and process input data through the Google Vertex AI platform. A deployed Vertex AI model is ready to receive predictions and provide responses. A langchain chain that uses the Vertex AI model. This involves using the langchain library to create a chain of operations that interact with the Vertex AI model. The chain utilizes the deployed Vertex AI model to perform predictions and incorporates the output parser to process the model's response. Fine-tune parameters: none. This means that the component does not require any specific configuration parameters to be fine-tuned for optimal performance. It can work out of the box with the default settings provided, simplifying its usage and integration into different workflows. Challenges and fixes. Challenge 1: the Vertex AI model might return an unexpected output format. This means that the model might provide the results in a structure or data format that is not anticipated by the output parser. For example, the model might return a list of values instead of a dictionary, or it might use different data types than expected. Fixes to challenge 1. Define a custom output parser to handle the unexpected format. This involves creating a specific parser tailored to the specific output format returned by the model. This custom parser can handle the specific data structures and types returned by the model, ensuring that the output is correctly parsed and formatted as a dictionary. Challenge 2: the Vertex AI model might return an error. This could occur due to various reasons, such as input data issues, model errors, or connectivity problems. Fixes to challenge to handle the error gracefully and provide a user-friendly message. This means implementing robust error handling mechanisms that catch and manage exceptions during the parsing process. When an error occurs, the component should provide a clear and informative message to the user, explaining the reason for the error and guiding them on potential solutions. This helps users understand and troubleshoot potential issues with the prediction process. Prerequisites. This section outlines the parameters for utilizing Google Vertex AI with LangChain, focusing on the interaction between functions and utilities. Inputs. Vertex AI endpoint. This refers to the deployed machine learning model on Google Vertex AI that you want to interact with. LangChain function. This represents a function defined within the LangChain framework that you want to integrate with your Vertex AI model. Outputs. Vertex AI prediction. The output of the machine learning model deployed on your Vertex AI endpoint, generated based on your input data. LangChain function output. This represents the output of the LangChain function, which you can use in conjunction with the Vertex AI prediction for further processing or decision making. Steps. 1. Define Vertex AI endpoint. 2. Define LangChain function. 3. Integrate with Vertex AI. 4. Execute function. Receive output. Prerequisites. Google Cloud Project. Project ID. A unique identifier for your Google Cloud project, essential for managing resources and permissions. API key. An application programming interface. API key is a secret key that grants access to Google Cloud services and resources. Vertex AI endpoint. Model deployment. This refers to the process of deploying your trained machine learning model onto Google Vertex AI, making it accessible for prediction requests. Fine-tune parameters. Endpoint URL. The unique web address of your deployed Vertex AI model endpoint. Function signature. The definition of the LangChain function, outlining its inputs, expected data types, and return values. Input data formatting. The structure and format of the data you intend to send as input to both the Vertex AI model and the LangChain function. Challenges and fixes. Endpoint connection issues. Verify API key. Confirm that the API key used for authentication is valid and has the necessary permissions to access your Google Cloud project. Check endpoint status. Verify that the Vertex AI endpoint is operational and ready to receive prediction requests. Ensure proper authentication. Check if you've correctly set up authentication for your application to access the Vertex AI endpoint using the provided API key. Function input mismatch. Adjust input formatting if the data format sent as input to the LangChain function does not match the expected format. Adjust the data formatting before sending it. Review function signature. Ensure that the data format and type of the input data you are providing to the LangChain function align with its definition. Output parsing errors. Implement output handling. Develop appropriate code to parse and interpret the output data from both the Vertex AI model and the LangChain function. Verify output data structure. Ensure that you understand the structure of the output data from both Vertex AI and the LangChain function to process it correctly. LangChain Google Vertex functions utils parameters schema summary. Description of inputs to the LangChain Google Vertex functions utils parameters schema summary. Description of function name in the context of LangChain Google Vertex functions utils parameters schema summary. The name of the function to be executed. For example, translate text or summarize document. Description of input arguments in the context of langchain Google Vertex functions utils. Parameters schema summary. The arguments required by the function. These should be in a format that the Vertex AI function can understand. For instance, for a translation function, the input argument could be the text to be translated. Description of outputs of the langchain Google Vertex functions utils parameters schema summary. Description of output values in the context of langchain Google Vertex functions utils. Parameters schema summary. The values returned by the Vertex AI function. This could be the translated text, summarized document, or any other output generated by the function. Description of steps to execute the langchain Google Vertex functions utils parameters schema summary. Description of retrieve function from Vertex AI in the context of langchain Google Vertex functions utils parameters schema summary. Fetching the specified Vertex AI function from the Vertex AI service. Description of input arguments to Vertex AI function in the context of langchain Google Vertex functions utils parameters schema summary. Passing the input arguments to the retrieved Vertex AI function. Description of output response from Vertex AI in the context of langchain Google Vertex functions utils parameters schema summary. Receiving the output response from the Vertex AI function. Description of convert Vertex AI response to langchain format in the context of langchain Google Vertex functions utils parameters schema summary. Transforming the Vertex AI function response into a format that langchain can readily understand and use. Description of prerequisites to execute the langchain Google Vertex functions utils parameters schema summary. Description of Google Cloud project in the context of langchain Google Vertex functions utils parameters schema summary. A Google Cloud project where the Vertex AI service and function are hosted. Description of GCP project ID in the context of langchain Google Vertex functions utils parameters schema summary. The unique identifier of the Google Cloud project. Description of Vertex AI API key in the context of langchain Google Vertex functions utils parameters schema summary. A key that grants access to the Vertex AI service. Description of API key in the context of langchain Google Vertex functions utils parameters schema summary. The actual value of the API key for authentication. Description of fine-tune parameters of the langchain Google Vertex functions utils parameters schema summary. Description of Vertex AI endpoint in the context of langchain Google Vertex functions utils parameters schema summary. The specific endpoint used to communicate with the Vertex AI service. Description of function version in the context of langchain Google Vertex functions utils parameters schema summary. The version of the Vertex AI function to be used. Description of challenges and fixes encountered while executing the langchain Google Vertex functions utils parameters schema summary. Description of function not found in the context of langchain Google Vertex functions utils parameters schema summary. The specified Vertex AI function could not be located. Description of verify function name correctness in the context of langchain Google Vertex functions utils parameters schema summary. Double check the function name for any typos or errors. Description of invalid input arguments in the context of langchain Google Vertex functions utils parameters schema summary. The input arguments provided are not compatible with the Vertex AI functions requirements. Description of ensure input arguments match function specification in the context of langchain Google Vertex functions utils parameters schema summary. Ensure the input arguments are in the correct format and structure as defined by the Vertex AI function. Description of Vertex AI API error in the context of langchain Google Vertex functions utils. Parameter schema summary. There is an issue with connecting to the Vertex AI service using PAY provided credentials. Description of check API credentials and connectivity in the context of langchain Google Vertex functions utils. Parameter schema summary. Verify that the API key is valid and that your system has a stable connection to the internet. Description of conversion error in the context of langchain Google Vertex functions utils. Parameter schema summary. An error occurred while trying to transform the Vertex AI response into a format langchain can use. Description of debug conversion logic in the context of langchain Google Vertex functions utils. Parameter schema summary. Examine the code responsible for converting the Vertex AI response and identify the specific issue leading to the error. Elaborated YAML for langchain Google Vertex AI functions utils. This represents the embedding functionality of Google Vertex AI, a platform that allows users to create and deploy machine learning models. This embedding component is designed to convert text data into numerical representations that can be used for various downstream machine learning tasks like similarity search, clustering, and classification. Inputs. This refers to the text data that needs to be converted into embeddings. The text can be a sentence, paragraph, or even a document. For example, if you want to find similar documents, you would provide the text of those documents as input. This is the name of the pre-trained model you want to use to generate the embeddings. Google Vertex AI provides a range of models suited for different tasks and languages. You can choose the best model based on your needs. Outputs. The output of this component is a list of floating point numbers representing the embedding of the input text. Each element in the list corresponds to a dimension in the embedding space. The closer two embeddings are in this space, the more similar the corresponding texts are. Steps. This step involves initializing the Vertex AI embeddings client. This client is responsible for interacting with the Vertex AI service and executing the embedding generation process. Once the client is initialized, this step involves calling the embeddings method on the client. This method takes the input text and the model name as arguments and returns the generated embeddings. Prerequisites. To use the Vertex AI embeddings component, you need a Google Cloud project. This project provides the necessary infrastructure and resources for hosting your models and data. The Vertex AI application programming interface API needs to be enabled in your Google Cloud project. This API enables your application to communicate with the Vertex AI service. The pre-trained model you want to use to generate embeddings must be deployed to Vertex AI. This process involves uploading the model to Vertex AI and configuring it for use. This enables the model to be accessible for embedding generation. This is the endpoint URL of the deployed model. The client uses this endpoint to access the model and generate embeddings. Fine-tune parameters. This is the name of the pre-trained model that you might want to fine-tune for your specific needs. Fine-tuning involves training the model on your own dataset to improve its performance on your specific task. This represents the version of the model you want to use. Different versions of the same model can have varying levels of performance, features, and capabilities. Challenges and fixes. If you encounter an error during the model initialization process, it could be because of issues with your application programming interface API key or project ID. To resolve this, make sure that you have a valid API key and that your project ID is correctly configured in your application. If the model you are trying to use is not found, It might be because the model name is incorrect or the model is not deployed to Vertex AI. You can check the model name and ensure that it is correct and deployed to the correct location. Langchain Google Genai LLMs. Langchain Google AI LLMs Summary. A langchain wrapper for Google AI's generative language models. It enables using Google AI models for tasks like text generation, translation, and summarization within the langchain framework. Inputs: text prompt or a dictionary of parameters. The input can be a simple text string, like write a poem about a cat, or a structured dictionary containing parameters specific to the Google AI model being used. Outputs: text response. The output of the langchain wrapper is the text generated by the Google AI model based on provided input. It could be a poem, a translated text, or a summarized version of the input text. Steps: initialize the Google AI application programming interface. This involves setting up the necessary authentication and connection to Google AI's services. Send the prompt to the Google AI model. The input prompt, either a text string or a dictionary, is sent to the selected Google AI model for processing. Receive in return the response. Once the Google AI model has processed the prompt, the generated response is received and returned by the langchain wrapper. Prerequisites: Google Cloud Platform account. To use Google AI models, you need a Google Cloud Platform account, Google Cloud project with an application programming interface key. A Google Cloud project is required to access the Google AI models, and it needs an application programming interface key for authentication. Google AI Platform Software Development Kit installed. The Google AI Platform Software Development Kit is essential to interact with Google AI services. Google AI Application Programming Interface enabled. You need to enable the Google AI Application Programming Interface in your Google Cloud project to access and use the available models. Fine-tune parameters. Temperature, a parameter that controls the randomness of the generated text. Higher temperature values produce more creative and surprising outputs, while lower values result in more predictable and consistent text. Top P, a parameter that limits the probability distribution of the next token in the generated sequence. It controls the diversity of the output by restricting the model's choices to a subset of the most likely tokens. Top K, a parameter that limits the number of candidate tokens considered for the next token in generated sequence. Like top P, it influences the diversity of the output by focusing on the most likely tokens. Max length, a parameter that limits the maximum length of the generated text. It helps control the output's length and prevent excessively long responses. Num return sequences, a parameter that specifies the number of different text sequences to generate for a single prompt. It allows exploring multiple variations of the response. Challenges and fixes. Rate limiting. Google AI services might impose rate limits to prevent overuse. Use a retry mechanism. Implementing a retry mechanism to handle rate limits by automatically reattempting requests after a delay can improve reliability and prevent disruptions. Application programming interface key usage. Improper usage of the application programming interface key can lead to security issues or billing problems. Use a service account. Utilizing a service account for authentication allows for better security practices and simplifies key management. Model availability. Not all Google AI models are available at all times. Check the model availability. It's essential to check the availability of the desired Google AI model before using it to avoid unexpected errors. Model versioning. Google AI models might have multiple versions with different capabilities or performance. Specify the desired version. Clearly specifying the version of the Google AI model ensures consistent results and avoids using outdated models. Cost of usage. Google AI services might incur charges based on usage. Monitor the usage. Regularly monitoring the usage of Google AI services helps track costs and manage expenses effectively. Langchain Google Vertex Gemma Chat Vertex AI Model Garden Summary. This document outlines the langchain integration with Google Vertex Gemma Chat, a powerful tool for building conversational AI applications. It leverages pre-trained models from Google Vertex AI to enable natural language interactions. Inputs. The text prompt or user query serves as the input for the Gemma Chat model. It represents the user's request or question, initiating the conversation. For instance, a user might input "What is the capital of France?" Outputs. The generated text response is the output of the Gemma Chat model. It represents the model's response to the user's input, providing information, answering questions, or engaging in a conversation. For instance, the model might respond to the input "What is the capital of France?" with "The capital of France is Paris." Steps. The first step involves initializing the Gemma Chat Vertex AI Model Garden by providing the necessary Vertex AI credentials. This establishes a connection to the Vertex AI platform and authorizes access to the pre-trained models. The second step involves loading the desired pre-trained model. Gemma Chat offers a variety of pre-trained models specializing in different tasks, such as text generation, question answering, or chatbot interaction. Choosing the appropriate model ensures optimal performance for the intended application. The third step involves passing the input prompt to the model for generation. This step triggers the model's processing of the input prompt and generates the corresponding output. Response. The final step involves processing the generated output. This step might include formatting, filtering, or further processing of the output response based on the specific requirements of the application. Prerequisites. A Google Cloud Platform project is necessary to access Vertex's Gemma Chat service. This project serves as a container for all resources related to the application, including the model, data, and code. An active Vertex AI application programming interface API is required within the Google Cloud Platform project to interact with Gemma Chat and its features. It allows the application to send requests and receive responses from the Gemma Chat service. The Google Cloud SDK is a set of tools and libraries that enable interaction with Google Cloud services from a local machine. This includes command-line tools for managing resources and deploying applications. The G-Cloud commands are part of the Google Cloud SDK and provide a powerful interface for interacting with various Google Cloud services, including Vertex AI. They allow users to manage projects, deploy models, and execute tasks related to Gemma Chat. Fine-tune parameters. Model selection refers to choosing the most suitable pre-trained model from the Gemma Chat library, based on the application's specific requirements. For example, if the goal is to build a chatbot for customer support, a model trained for conversational tasks would be a better choice than a model trained for text. Summarization. Temperature is a parameter that controls the randomness of the generated text. A higher temperature value leads to more creative and unpredictable outputs, while a lower temperature value results in more predictable and coherent text. Top K is a parameter that limits the number of possible words to consider during text generation. It helps to ensure that the generated text is relevant and coherent. Top P is a parameter that controls the probability distribution of the words to be considered. During text generation, it allows for fine-tuning the balance between diversity and coherence in the generated text. Challenges and fixes. A model not found error might occur if the specified model does not exist in the Vertex AI project, or if the API or model configuration is incorrect. This can be resolved by verifying the project, API, and model configurations to ensure they are properly defined and accessible. Authentication issues might arise if the Google Cloud credentials are invalid or if the Google Cloud SDK is not set up correctly. These issues can be addressed by verifying the credentials and ensuring the SDK is properly installed and configured. Input prompt parsing errors can occur if the prompt is formatted incorrectly or if its structure does not align with the model's expectations. To resolve this, refine the prompt formatting and structure, ensuring it is clear, concise, and formatted according to the model's requirements. This might involve using specific keywords, structuring the prompt in a logical way, or providing clear context. Langchain Google Vertex Gemma Local Kaggle Summary. This flow utilizes Kaggle datasets for training a model, which is subsequently deployed onto Vertex AI. Inputs. The path to a Kaggle dataset. This could include a dataset path like dataset's username, dataset name, name of the Vertex AI endpoint. This endpoint will be used for model deployment and serving predictions. Outputs. The trained model. This model has been trained using the provided Kaggle data. The deployed model. The trained model is hosted on Vertex AI and can be used for predictions. Steps. This step involves downloading the Kaggle dataset. Using the Kaggle API, the specified dataset is downloaded from the Kaggle platform. Prepare the data for training. Data preprocessing is crucial for model training and involves cleaning, transforming, and preparing the Kaggle dataset. Train a model using Vertex AI. The preprocessed Kaggle dataset is used to train a machine learning model within the Vertex AI platform. Deploy the trained model to Vertex AI. The trained model is deployed as a service on Vertex AI, making it ready for predictions. Prerequisites. Google Cloud Project. A Google Cloud project is required to access Vertex AI services and manage resources. The unique ID of your Google Cloud project. For example, GCP Project 1234. Vertex AI Service Account. A Vertex AI Service account is used for authentication and authorization within the Vertex AI platform. The email address associated with the Vertex AI Service account. An example is Vertex iService account GCP project 1234.in.gserviceaccount.com. Fine-tune parameters. Model architecture. This specifies the type of machine learning model being used. Examples include linear regression, neural networks, or decision trees. Hyperparameters. These parameters control the model's training process and learning behavior. For example, learning rate, number of layers, or regularization. Challenges and fixes. Issues downloading the Kaggle dataset. This could be due to network connectivity problems. Issues with Kaggle application programming interface API credentials, or the specified dataset being unavailable. Verify internet connectivity and ensure the Kaggle API credentials are valid and authorized to access the desired dataset. Confirm that the dataset actually exists on Kaggle and is accessible. Errors during Vertex AI model training. These could include code errors, insufficient resources, or data quality issues. Check the training code carefully for errors. Ensure sufficient resources are allocated for training, including processing power and memory. Review the dataset quality for inconsistencies, missing values, or potential biases. Deployment failures on Vertex AI. These may be caused by misconfigurations, incorrect model format, or insufficient resource allocation. Ensure proper Vertex AI configuration for deployment. Verify that the model is saved in a format compatible with Vertex AI. Allocate sufficient resources like compute instances for the deployed model. Langchain Google Vertex Gemma Local Kaggle. Gemma Local Kaggle is a langchain component that allows you to use Google Vertex's Gemma service to train and deploy machine learning models locally using Kaggle datasets. Inputs: a URL that points to a dataset hosted on the Kaggle platform, containing the data required for training the machine learning model. Example: https www.kaggle.com datasets Catherine Luo student performance in exams. A configuration file that details the architecture and tuning parameters for the machine learning model to be trained. Example: a configuration file that specifies the model type is random forest. The number of trees is 100. And the maximum depth of each tree is 5. Outputs: the trained machine learning model, ready for deployment and making predictions on unseen data. Example: a trained random forest model with the specified hyperparameters, trained on the student performance dataset. Metrics that quantify the performance of the trained machine learning model, providing insights into its accuracy, precision, and other relevant measures. Example metrics such as accuracy, precision, and recall scores, calculated by evaluating the model's performance on a holdout dataset. Steps: downloading the Kaggle dataset from the provided URL, ensuring it is locally accessible for subsequent processing steps. Example: using the Kaggle API, downloading the student performance dataset from the specified URL and storing it locally. Transforming the downloaded Kaggle dataset into a suitable format for training the machine learning model. This might involve cleaning, pre-processing, or feature engineering steps. Example: cleaning the student performance dataset by handling missing values, converting categorical features to numerical representations, and selecting relevant features for the model. Utilizing the Google Vertex's Gemma service to train the machine learning model based on provided model configuration and the prepared dataset. Example: leveraging the Gemma service to train a random forest model with the specified hyperparameters, using the preprocessed student performance dataset. Evaluating the performance of the trained machine learning model using a separate holdout dataset. Or cross-validation techniques, generating metrics to assess its effectiveness. Example: evaluating the performance of the trained random forest model by splitting the dataset into training and test sets, predicting on the test set, and calculating metrics like accuracy and precision. Prerequisites: an account on the Google Cloud Platform, allowing access to the Vertex AI service and its associated features. Example: creating a Google Cloud Platform account and enabling billing for the project. A Google Cloud Platform project that serves as the organizational unit for managing resources and accessing services within the platform. Example: creating a new Google Cloud Platform project called Student Performance Model to manage resources related to training and deploying the model. The Vertex AI Application Programming Interface API enabled for the Google Cloud Platform project, providing access to the Gemma service for model training and deployment. Example: enabling the Vertex AI API within the Student Performance Model project using the Google Cloud Console or the G-Cloud command line tool. Authentication credentials for accessing the Kaggle API, enabling the download of datasets from the Kaggle platform. Example: obtaining a Kaggle username and generating an API key to authenticate with the Kaggle platform. A Kaggle username that identifies the user on the Kaggle platform. Example: John Doe is the Kaggle username. A Kaggle API key associated with the Kaggle username, granting access to the platform's features, including dataset download. Example: your API key obtained from the Kaggle account settings. Fine-tune parameters. Parameters that can be adjusted to optimize the performance of the machine learning model, such as learning rate, number of epochs, and regularization strength. Example: tuning the learning rate of the random forest model to improve its convergence and accuracy. Configuration options for customizing the Gemma service environment, including the geographical region for model training and the type of machine resources to be utilized. Example: specifying the region as US Central 1 and choosing the machine type as N1 Standard 1 for the Gemma service. Influencing the model training time and cost. Challenges and fixes. Issues encountered when downloading Kaggle datasets, potentially caused by incorrect API credentials or network connectivity problems. Example: if the Kaggle API key is invalid or the internet connection is unstable, the dataset download might fail. Verify the correctness of the Kaggle API credentials, including the username and API key, ensuring they are valid and properly configured. Example: double-checking the Kaggle username and API key, making sure they match the values provided in the configuration settings. Assessing the network connectivity. Confirming a stable internet connection is available for accessing the Kaggle platform and downloading the dataset. Example: testing the internet connection by visiting a website or running a network diagnostic tool. Errors encountered during the model training process, potentially caused by insufficient compute resources, inappropriate hyperparameter settings, or data preparation issues. Example: the model training might fail if the machine resources are inadequate for handling the complexity of the dataset or if the hyperparameters are not optimized for the specific model and data. Ensure sufficient compute resources are allocated to the Gemma service for training the model efficiently, avoiding resource limitations. Example: increasing the machine type used by the Gemma service to provide more CPU and memory resources, enabling faster and more efficient training. Carefully adjust the model hyperparameters based on the dataset characteristics and the model architecture to optimize the training process and achieve desired performance. Example: experimenting with different learning rates, number of epochs, and regularization strengths to find the optimal configuration for the random forest model. Thoroughly review the data preparation steps, ensuring that the data is correctly cleaned, pre-processed, and prepared for training, eliminating potential errors or inconsistencies. Example: checking for missing values, handling categorical features appropriately, and selecting relevant features for the model. Ensuring data quality and consistency for effective training. Langchain Google Vertex AI Gemma messages to prompt. A comprehensive explanation of the langchain Google Vertex AI Gemma messages to prompt component. A list of Gemma messages representing the conversation history between a user and an assistant. An optional custom prompt template that allows users to tailor the prompt structure according to their specific needs. A langchain prompt designed to effectively utilize the information extracted from the Gemma messages. The component extracts relevant information from the Gemma messages. This process involves identifying key elements such as user questions, assistant responses, and contextual information. The extracted information is then formatted into a well-structured prompt suitable for use with langchain. The prompt is designed to guide the language model to generate responses that are consistent with the conversation context and user intent. Gemma messages. which are the fundamental input for the component. These messages encapsulate the conversational history between a user and an assistant. Example: a user asks what is the capital of France. The assistant responds Paris. A langchain prompt template, which provides a basic structure for the generated prompt. It can be customized to align with specific use cases. Example: I am a helpful assistant. Context: what is the capital of location? This template allows for dynamic insertion of context and location information from the genai. Messages. The prompt template serves as a parameter for fine-tuning the generated prompt. This allows users to customize the structure and content of the prompt according to their specific requirements. The genai message format is another parameter that influences the prompt generation process. Different message formats require adjustments in the extraction and formatting steps. Handling multiple turns in the conversation can be challenging. To address this, the component employs a structured approach to format the context, ensuring that the prompt accurately reflects the conversation history. Extracting relevant information from the genai messages requires defining clear extraction rules. This ensures that only pertinent information is included in the prompt, improving its quality and efficiency. Langchain Google Vertex genai messages to prompt. This component is responsible for converting a list of user and assistant messages into a prompt that is suitable for a large language model (LLM). This process involves understanding the structure of the messages, extracting the relevant information, and formatting them in a way that the LLM can easily interpret. Inputs. This component expects a list of genai messages as its input. These messages are structured as dictionaries, each containing two keys: role and content. The role key specifies whether the message was sent by the user or the assistant, while the content key holds the actual message text. For example, JSON, role user. Content: what is the capital of France? Role assistant. Content: the capital of France is Paris. Outputs. The output of this component is a single string representing the prompt. It is generated by concatenating the user and assistant messages from the input list, while appropriately formatting them according to the requirements of the target LLM. For example, the prompt for the above input might look like this. User: what is the capital of France? Assistant: the capital of France is Paris. Steps. The component iterates through the list of genai messages, one by one. For each message, it determines the role of the message user or assistant and constructs a string representation of the message, including its role. For example, for the first message in the example above, the constructed string might be user: what is the capital of France? Once all the messages have been processed, the component concatenates the constructed strings to form the final prompt. This prompt is then ready to be sent to the LLM for processing. Prerequisites. The input list of genai messages must adhere to the specified format, with each message containing a role key indicating whether it is from the user or the assistant. Fine-tune parameters. This component does not have any fine-tuning parameters. Its behavior is determined solely by the structure of the input messages and the target LLMs. Requirements. Challenges and fixes. Messages might contain special characters or formatting that could cause problems when interacting with the LLM. These characters and formatting need to be properly escaped or adjusted to ensure the LLM can understand the prompt correctly. To address this challenge, the component should include logic to escape special characters and format the messages according to the LLM's requirements. For instance, if the LLM expects prompts to be formatted in a specific way, such as using a particular delimiter to separate user and assistant messages. The component needs to handle this formatting. Langchain Google Vertex LLMs. This YAML file describes the integration of Google Vertex AI models with langchain, a powerful framework for building and deploying natural language processing applications. By leveraging Vertex's advanced machine learning capabilities, langchain empowers developers to create sophisticated NLP solutions that handle tasks such as text classification, translation, summarization, and more. Inputs. The textual input that the Vertex AI model will process. This could be a sentence, paragraph, document, or any other type of text data. For example, if you are building a sentiment analysis application, the input could be a customer review. Configuration parameters for the Vertex AI model. These parameters specify the specific model you want to use, along with any necessary settings. For instance, you might specify the model's name, version, and deployment location. Outputs. The output produced by the Vertex AI model after processing the input text. This output will depend on the specific task the model performs. For example, if the model is a sentiment analysis model, the output might be a sentiment score indicating whether the input text is positive, negative, or neutral. Predictions generated by the Vertex AI model. These predictions can take many forms, depending on the model's function. Examples include classifications categorizing text into predefined classes, translations converting text from one language to another, or summaries generating concise summaries of longer texts. Steps. Initialize a langchain Vertex AI LLM instance. This step creates a langchain object that represents the Vertex AI model and its associated configuration. Provide the input text to the langchain Vertex AI LLM instance. This step feeds the text data into the langchain object, making it ready for processing by the Vertex AI model. Invoke the Vertex AI model to process the input text. This is the core step where the langchain object sends the input text to the Vertex AI model for analysis and processing. Retrieve and interpret the model's output. This step involves retrieving the results produced by the Vertex AI model and converting them into a format that is understandable and usable within the langchain application. Prerequisites. A Google Cloud Platform account is necessary to access and utilize Google Vertex AI services. You also need a Google Cloud Platform project that has Vertex AI enabled. This ensures that your project has the necessary resources and permissions to work with Vertex AI models. A Vertex AI model that has been trained and deployed is essential for the langchain integration to function. This model should be ready to accept and process input text. A Vertex AI application programming interface key is needed to authenticate and authorize access to the Vertex AI model from your langchain application. This key provides secure access to the model's resources and ensures that only authorized users can interact with it. Fine-tune parameters. Model selection involves choosing the appropriate Vertex AI model for your specific natural language processing task. This choice depends on factors such as the type of input data, the desired output, and the model's capabilities. Input text preprocessing refers to the steps taken to prepare the input text for the Vertex AI model. This can include tasks like cleaning the text, removing irrelevant information, or converting it to a format that the model can understand. For instance, you might remove punctuation or convert text to lowercase. Output interpretation involves defining how to understand and use the output generated by the Vertex AI model. This might involve mapping the model's raw output to specific categories, extracting key information, or formatting the output for display in your application. For example, you might translate numerical sentiment scores into human-readable labels like positive, negative, or neutral. Challenges and fixes. Authentication issues can arise if there are problems with the configuration of your Google Cloud Platform project or the setup of the Vertex AI application programming interface key. Ensure that your project is properly configured and that the API key is correctly set up to access the Vertex AI services. Model access limitations might occur if the Vertex AI model is not properly deployed or if you lack the necessary permissions to interact with it. Verify that the model has been deployed successfully and that you have the required permissions to access and utilize it. Input data formatting discrepancies can happen if the format of your input text does not match the expectations of the Vertex AI model. Align the format of your input data with the model's requirements to ensure correct processing. For example, if the model expects input in a specific format, like JSON, make sure your input text is converted to that format before sending it to the model. Output interpretation errors can occur if the mapping between the model's output and your desired interpretation is not defined clearly. Define precise output mappings and validation rules to ensure that you accurately understand and utilize the results generated by the model. This might involve creating lookup tables or using specific algorithms to translate the model's output into meaningful information. Langchain Google Vertex Gemma Chat Local Kaggle. A langchain tool that leverages the Google Vertex AI Gemma application programming interface API for executing Gemma chat models directly on a local machine using a Kaggle kernel. This tool allows users to interact with Gemma models without needing a remote server or a dedicated cloud environment. Inputs: the directory location of the Kaggle kernel file on the local machine. This kernel file contains the code for interacting with the Gemma model and generating chat responses. An example could be C users John desktop Kaggle kernel IPYNB. The file path to the downloaded Gemma model on the local machine. This model file contains the trained parameters and configurations of the Gemma chat model. An example path could be C users John downloads Gemma model H5. Outputs: a textual representation of a chat-like conversation generated by the Gemma chat model. The output would include the user's prompts and the corresponding responses generated by the model, creating a natural conversation flow. Steps: the initial step involves installing the necessary libraries required for interacting with Gemma and running the model on the Kaggle kernel. This usually involves using the pip package manager to install libraries like langchain, TensorFlow, and other relevant dependencies. The downloaded Gemma model is then loaded into the Kaggle kernel. This step involves using the appropriate libraries and methods to read the model file and initialize it within the kernel's environment. The Gemma Chat local Kaggle tool is initialized with the loaded Gemma model and other required configurations. This involves setting up the necessary parameters and connections for the tool to function properly. The tool is executed to generate a chat conversation. The user interacts with the tool by providing prompts, and the tool uses the loaded Gemma model to generate responses based on the input prompts. Prerequisites: an active Kaggle account is necessary to access and use Kaggle kernels for running the Gemma model. This involves creating a Kaggle profile and setting up a new kernel within the Kaggle platform. A Gemma model is required for the tool to function. This model is obtained by downloading a pre-trained Gemma chat model from the Vertex AI platform. The Vertex AI Application Programming Interface API can be used to retrieve and download a desired genai model. Fine-tune parameters. The model name parameter specifies the unique identifier or name of the genai model that will be used for chat generation. This parameter helps in selecting the correct model from the available options. An example could be genai chat large. The model path parameter indicates the file path on the local machine where the downloaded genai model is located. This path is used to locate the model file and load it into the Kaggle kernel for processing. An example could be C users John downloads genai model H5. Challenges and fixes. If the necessary libraries are not installed, the tool might fail to load or execute properly. This can be resolved by installing the missing libraries using the pip package manager. The command pip install langchain TensorFlow can be used to install the required libraries. The genai model might not load correctly if the path specified is incorrect or the model file is corrupted. Ensuring the correct path is provided and verifying that the model file was downloaded successfully can resolve this issue. Langchain Google Vertex LLMs. Integrate Google Vertex AI with langchain. Facilitating the seamless use of Vertex is powerful language models within langchain's framework. Inputs. The endpoint associated with the Vertex AI model, acting as the gateway to access the model's capabilities. The text prompt containing the user's query or instruction for the Vertex AI model to process and generate a response. Outputs. The generated text, a response generated by the Vertex AI model based on the provided text prompt. Steps. Initiate the langchain library, setting up the environment for interacting with Vertex AI. Create a Vertex AI LLM object within langchain. Specifying the necessary parameters and configurations for accessing and utilizing the Vertex AI model. Submit the text prompt to the created Vertex AI LLM, triggering the model's processing and generation of a response. Retrieve the generated text output from the Vertex AI LLM, capturing the model's response to the provided text prompt. Prerequisites. An active Google Cloud account is required to access and utilize Vertex AI services, including deploying models and managing resources. The Vertex AI endpoint is a fundamental component, serving as the entry point for interacting with the deployed Vertex AI model. A Vertex AI application programming interface API key is a necessary credential for authenticating and authorizing access to Vertex AI resources, enabling secure and controlled communication. Your Vertex AI API key refers to your unique API key, essential for accessing your specific Vertex AI resources. Fine-tune parameters. Temperature. A parameter influencing the randomness and creativity of the generated text, with higher values leading to more diverse and unpredictable outputs. Top K. A parameter controlling the selection of the most likely tokens during text generation, limiting the generation to the top K most probable tokens, reducing the output's randomness. Top P. A parameter controlling the probability distribution of tokens during text generation, selecting tokens from a distribution where the cumulative probability reaches a specified threshold. P. Balancing randomness and relevance. Challenges and fixes. An incorrect API key can lead to access issues and errors when attempting to interact with Vertex AI services. Verify API key by ensuring the provided key matches the one associated with your Google Cloud account and the desired Vertex AI project. Endpoint not found errors occur when the provided Vertex AI endpoint does not correspond to a valid and deployed model. Check endpoint name. confirming that the provided name accurately reflects the deployed Vertex AI model. Invalid prompt format can prevent successful processing and response generation by the Vertex AI model, resulting in unexpected outputs. Format prompt correctly by structuring the prompt with valid syntax and language, ensuring compatibility with the Vertex AI model's capabilities. Insufficient resources, like insufficient compute power or memory allocated to the Vertex AI model, can hinder performance and response generation, leading to delays or errors. Increase Vertex AI resources by adjusting the allocated resources, such as CPU, RAM, or GPU, based on the model's requirements and the complexity of the tasks being performed. Prerequisites: a description of the Vertex AI Model Garden, which is a platform that uses Google Vertex AI to simplify the process of training, deploying, and monitoring language models. Inputs: the input of the Vertex AI Model Garden is a Vertex AI instance, which is a managed service that provides the infrastructure and tools for training and deploying machine learning models. The second input is model training data, which is the data that is used to train the language model. This data can be in various formats, such as text files, CSV files, or databases. Outputs: the output of the Vertex AI Model Garden is a trained and optimized language model. This model can be used to perform various tasks, such as text generation, translation, and summarization. The second output is the deployment of the trained model to a Vertex AI endpoint. This endpoint allows users to access and use the trained model through an application programming interface API. Steps: 1. Prepare your data. 2. Define your model architecture. 3. Train your model on Vertex AI. 4. Evaluate model performance. 5. Deploy the trained model. 6. Monitor the model in production. Prerequisites: Google Cloud Project. You need a Google Cloud project to use the Vertex AI Model Garden. This project will be used to store your data, models, and other resources. You will need to set up billing for your project and enable the necessary application programming interfaces APIs for Vertex AI. Vertex AI Service. Enable the Vertex AI Application Programming Interface API and create a Vertex AI instance. The Vertex AI instance will provide the infrastructure and tools for training and deploying your models. Fine-tune parameters. Hyperparameters. These are parameters that control the training process of the language model. They include parameters like learning rate, batch size, and epochs. The learning rate controls how quickly the model learns from the training data. The batch size controls how many data points are used to update the model parameters in each training step. The number of epochs controls how many times the model is trained on the entire dataset. Model architecture. The model architecture defines the structure of the language model. This includes the number of layers, the number of units in each layer, and the type of activation functions used. You can customize the model architecture to suit your specific needs. Challenges and fixes. Challenge 1. Data preparation issues can occur if the data is not in the correct format or if some features are missing. This can lead to inaccurate model training and poor performance. Fixes to Challenge 1. To fix these issues, you can clean and pre-process the data to ensure that it is in the correct format. You can also handle missing values by imputing them with appropriate values or removing the data points with missing values. Challenge 2. Model training time or resource limitations can occur when training large models with large datasets. Overfitting can occur when the model performs well on the training data but poorly on unseen data. Underfitting can occur when the model is not complex enough to capture the patterns in the data. Fixes to challenge 2. To address these challenges, you can optimize the hyperparameters, such as the learning rate and batch size. You can also use techniques such as early stopping to prevent overfitting. If the model is underfitting, you can adjust the model architecture to make it more complex. Challenge 3. Deployment challenges can occur when deploying a trained model to a Vertex AI endpoint. These challenges can include latency issues or model performance degradation. Latency issues occur when the model takes too long to process requests. Model performance degradation occurs when the model's performance decreases over time. Fixes to challenge 3. To address these challenges, you can optimize the model architecture to reduce the computational cost of inference. You can also use model compression techniques to reduce the size of the model, which can improve latency. If the model's performance degrades over time, you can update the model by retraining it on new data. Langchain Google Vertex Model Garden Vertex AI Model Garden. This model garden provides a comprehensive overview of utilizing Google Vertex AI to build, deploy, and manage langchain applications, thereby streamlining the development and operationalization process. Inputs. Langchain applications, such as chatbots and summarizers, are built using the langchain framework and are designed to interact with various language models and data sources to perform specific tasks. A Vertex AI project serves as the environment for hosting and managing the deployed langchain application, enabling centralized control and resource management for AI models. Outputs. The langchain application, packaged and deployed to a Vertex AI endpoint, becomes accessible to users through a managed interface. Logs and metrics are collected and analyzed to monitor the application's performance, identify potential issues, and optimize its behavior over time. Steps. The langchain application is packaged into a deployable unit, ensuring that all necessary components, such as code, libraries, and dependencies, are bundled together. A Vertex AI endpoint is created within the Vertex AI project, serving as the designated point of access for the deployed langchain application. The packaged langchain application is deployed to the Vertex AI endpoint, making it available to users through the Vertex AI platform. Prerequisites. A Google Cloud project is required to host the Vertex AI environment and provide the necessary infrastructure for the deployed langchain application. Google Cloud AI Platform, GAPIC, Services, Model Service. Model Service Client refers to the specific client library used to interact with Vertex AI services and manage deployed models. The Vertex AI Software Development Kit (SDK) provides a set of tools and libraries for developers to interact with the Vertex AI platform programmatically, simplifying the development, deployment, and management of AI applications. Vertex AI SDK enables seamless integration with the Vertex AI platform, streamlining the process of working with models and data. Fine-tune parameters. The selection of the model for the application is crucial, and different models excel in various tasks. Factors like model size, training data, and specific capabilities should be considered when choosing a suitable model. Deployment configuration involves defining resource allocation, access control, scaling policies, and other parameters that optimize the application's performance and resource utilization. Challenges and fixes. Errors encountered during deployment can arise from issues within the application code. Deployment configuration. or underlying infrastructure. Thorough review of the application code, deployment configuration settings, and system logs can help pinpoint the source of the deployment error. Slow application performance can be attributed to factors such as inefficient code, insufficient resource allocation, or network latency. Optimizing the application code, increasing resource allocation for the application, and minimizing network latency can significantly improve the application's speed and responsiveness. LangChain Google Vertex AI LLM's Vertex AI integration. This integration leverages the power of Google Vertex's large language models LLMs within the framework of LangChain. It allows for seamless interaction with LLMs for tasks such as text generation, translation, and summarization while utilizing LangChain's capabilities for building complex conversational AI systems. Inputs. Text prompts serve as the input to the LLM, guiding its text generation process. For example, a prompt like "write a short story about a cat who goes on an adventure" would trigger the LLM to generate a creative story based on that prompt. Vertex AI endpoint configuration provides the connection details for accessing the LLM model deployed on Vertex AI. This includes the endpoint URL, authentication credentials, and other necessary parameters to establish a secure connection. Outputs. The LLM's generated text output represents the result of its processing of the input prompt. This output can be a variety of textual formats, ranging from simple sentences to complex narratives, depending on the LLM's capabilities and the prompt's instructions. Model usage statistics offer insights into the LLM's performance and resource consumption during the interaction. This includes metrics like the number of tokens processed, the execution time, and any associated costs. Steps. Defining a LangChain LLM wrapper for Google Vertex AI allows for a standardized way to interact with the LLM through the LangChain library. This wrapper handles the communication protocols, authentication mechanisms, and other technical aspects of interacting with the Vertex AI endpoint. Configuring the Vertex AI endpoint involves providing the necessary details for establishing a connection to the deployed LLM model. This includes specifying the endpoint URL, authentication credentials, and any other required parameters. Sending prompts to the LLM using LangChain involves passing the text prompt through the LangChain LLM wrapper. This allows for seamless integration of the prompt with the Vertex AI endpoint, triggering the LLM to process the input and generate text output. Processing the LLM response within LangChain entails handling the generated text output from the Vertex AI endpoint. This includes extracting the generated text, formatting it according to the desired output format, and potentially further processing it using LangChain's capabilities. Prerequisites. A Google Cloud Platform account is required to access and utilize the Vertex AI service, which hosts the LLM models. This account needs to have a project enabled for the Vertex AI Application Programming Interface API, granting permission to interact with the Vertex AI service. A Vertex AI endpoint configured with a suitable LLM is essential for the integration to work. This requires deploying an LLM model to a Vertex AI endpoint, making it accessible for use by LangChain. Fine-tune parameters. LLM model selection involves choosing the specific LLM model from the available options on Vertex AI that best suits the desired task. This selection is based on the model's capabilities, performance, and resource requirements. Temperature and top-K parameters are used to control the creativity and randomness of the LLM's text Generation. Temperature adjusts the probability distribution of possible words, with higher values leading to more diverse and surprising outputs. Top K limits the number of possible words considered during generation, influencing the overall coherence and consistency of the generated text. Challenges and fixes. Authentication issues with Vertex AI can arise if the langchain wrapper is not correctly configured with the necessary credentials. Ensuring correct credentials are configured in the langchain wrapper is crucial for establishing a secure connection to the Vertex AI endpoint and accessing the deployed LLM. Handling model latency and resource limitations is a common challenge when working with LLMs. Consider optimizing prompts for efficiency, using more concise and specific prompts to minimize the processing time. Employ caching techniques to store and reuse previously generated outputs, reducing the need for redundant requests to the LLM. Langchain Google Vertex Gemma Local Kaggle Summary. This langchain tool enables seamless integration of Kaggle datasets into your Vertex AI projects. It simplifies the process of accessing, processing, and using Kaggle data within the Vertex AI environment, streamlining your machine learning workflows. Inputs: the path to the local Kaggle dataset on your machine. For example, if you've downloaded the Titanic dataset from Kaggle and saved it in your datasets folder, the path would be datasets.titanic.csv. The name of the Kaggle dataset you wish to use, such as Titanic, Must, or IMDb reviews. Outputs: details about the dataset, including its size, columns, data types, and potential missing values. The contents of the dataset itself, ready for use in your machine learning model training or analysis. Steps: the tool first retrieves metadata about the specified Kaggle dataset. This metadata includes information like the dataset's name, description, columns, and data types. The tool then downloads the dataset from Kaggle and processes it locally. This processing may involve cleaning the data, handling missing values, and converting data types as needed. Prerequisites: credentials required to access the Kaggle Application Programming Interface API. These credentials authorize the tool to interact with the Kaggle platform and retrieve your datasets. A unique key generated by the Kaggle platform, allowing the tool to authenticate with the Kaggle API. Your Kaggle username, used to identify your account and associated datasets. The Kaggle dataset itself, downloaded locally to your machine. The tool requires access to the downloaded dataset for processing and integration into Vertex AI. The actual dataset file, typically in a format like CSV, JSON, or other structured data formats, stored on your machine. Fine-tune parameters: how the dataset should be split into training, validation, and test sets for your machine learning model. This could involve random splitting, time-based splitting, or other methods depending on your specific needs. Techniques applied to the dataset's features, such as scaling, normalization, or transforming categorical variables into numerical representations. These steps can enhance the performance of your machine learning models. Challenges and fixes: issues with network connectivity, preventing the tool from accessing the Kaggle API. Check your network settings to ensure proper internet connectivity. Verify that the Kaggle API is reachable and accessible from your machine. Errors downloading the dataset from Kaggle. Ensure that the dataset you are trying to download exists and is publicly available on Kaggle. Confirm that your Kaggle API access is working correctly and authorized to download datasets. Problems processing the dataset locally after download. Examine the dataset's format and structure to identify potential data inconsistencies or errors. Apply appropriate data transformations or cleaning techniques to resolve any data formatting issues. Difficulties integrating the processed dataset into your Vertex AI environment. Ensure that your Vertex AI environment is properly configured and set up. Define a data ingestion pipeline that correctly imports the processed dataset into Vertex AI for use with your machine learning models. Langchain Google Vertex Vector Stores Document Storage GCS Document Storage. A description of the langchain Google Vertex AI Vector Stores Document Storage GCS Document Storage component. This component is a specialized document storage mechanism within langchain that leverages Google Cloud Storage GCS for efficient and scalable management of textual data. This is crucial for large language models (LLMs) and vector databases, as it allows for storing and retrieving documents efficiently, even when dealing with massive datasets. Inputs. Raw text documents. This refers to the original text data that needs to be stored. These can be articles, books, emails, or any other form of text content. GCS bucket URI. This is the unique identifier for the Google Cloud Storage bucket where the documents will be stored. It is a string that specifies the location of the bucket within the Google Cloud Platform. For example, GSMY bucket. Outputs. Stored documents in GCS. The component stores the processed documents in the specified GCS bucket. This makes the documents accessible for retrieval and processing by LLMs or vector databases. Document metadata. This refers to additional information associated with each document, such as its title, author, creation date, or any other relevant details. Metadata helps in organizing and searching for documents. Steps. 1. Documents are converted to a format suitable for storage. The component converts the raw text documents into a format that is optimized for storage in GCS. This might involve converting the text to a specific encoding or splitting large documents into smaller chunks. 2. Documents are uploaded to the specified GCS bucket. The component uploads the processed documents to the designated GCS bucket. This ensures that the documents are stored securely and efficiently within the Google Cloud infrastructure. 3. Metadata associated with each document is stored. The component also stores the metadata associated with each document, such as the document title, author, creation date, or any other relevant details. This metadata helps in organizing and searching for documents within the GCS bucket. Prerequisites. Google Cloud Project. You will need an active Google Cloud project to use this component. This project provides the necessary infrastructure and resources for storing and managing your documents in GCS. Project ID. This is the unique identifier for your Google Cloud project. It is used to access the resources and services within the project. It's a string. For example, my GCP project ID. GCS bucket. You will need a Google Cloud Storage GCS bucket to store your documents. This bucket is a container for your data in the Google Cloud Platform. It is a string. For example, my bucket. Bucket name. This is the name of your GCS bucket. It is used to identify the bucket within the Google Cloud Platform. For example, my bucket. Fine-tune parameters. Chunk size of each document chunk. This parameter determines the size of each document chunk when the documents are split for storage. This helps to optimize the storage and retrieval process, especially for large documents. Chunk overlap between chunks. This parameter determines the amount of overlap between adjacent document chunks. Overlap helps to ensure that the context is preserved across chunks. which is important for tasks like question answering and document summarization. Challenges and fixes. Document size limitations. Large documents might exceed the storage limits of a single object in GCS. Use chunking or consider alternative storage options to address this. The component allows you to split large documents into smaller chunks. Alternatively, consider using other storage options that can handle larger files, such as cloud-based databases or object storage services specifically designed for large files. Data security and access control. Protecting your data is crucial. Implement appropriate GCS permissions and encryption to ensure data security and control access to your stored documents. Implement appropriate GCS permissions and encryption. You can control who has access to the GCS bucket and the stored data. Additionally, you can encrypt the data both at rest and in transit to protect it from unauthorized access. Langchain. Google Vertex Vector Stores. Vector Stores. Vector Search. Vector Store. A vector store that leverages Google Vertex AI to store and retrieve vectors, facilitating efficient similarity search across text documents. Inputs. A collection of text documents, representing the data to be indexed and searched. A corresponding set of embeddings for each text document, capturing the semantic meaning of the text in a numerical format. Outputs. A list of text documents, retrieved based on their similarity to a query. A list of embeddings for each retrieved text document. Steps. Instantiate a vector search vector store object, providing the necessary configuration for accessing the Vertex AI service. Load the prepared text documents and their respective embeddings into the vector store, indexing them for efficient retrieval. Employ the vector store's similarity search methods, such as similarity search, to retrieve relevant documents based on a provided query. The search uses the embeddings to find documents with similar semantic content. Prerequisites. An active Google Cloud Platform account, providing access to the Vertex AI service. The Vertex AI service enabled within your Google Cloud project. A configured Vertex AI endpoint, specifically designed for embedding models, to process text and generate embeddings. The endpoint should be associated with a suitable embedding model, like sentence transformers, which can effectively capture the semantic meaning of text. Fine-tune parameters. Top-K specifies the number of most relevant documents to be retrieved during a similarity search. This parameter controls the size of the results set. Similarity threshold sets a minimum similarity score required for a document to be considered relevant and included in the results. Documents with scores below this threshold are excluded. Embedding function defines the function responsible for mapping text into numerical embeddings. It determines the representation of text used for similarity search. Index name identifies the specific Vertex AI index used for storing and retrieving embeddings. This allows for organization and management of multiple indices within the Vertex AI service. Challenges and fixes. Incorrect Vertex AI endpoint configuration. Verify that the endpoint is configured correctly, ensuring that it points to the desired embedding model and that the application programming interface API key used for authentication is valid. Insufficient data for similarity search. Increase the size of the dataset used for training the embedding model and creating the Vertex AI index. More data can improve the model's ability to generate meaningful embeddings and enhance search accuracy. Slow retrieval times. Optimize the Vertex AI index for faster search performance. This can be achieved by adjusting index parameters, such as the number of shards or the indexing strategy. Consider using a more efficient embedding model. such as those specialized for speed or optimized for a specific domain. Insufficient similarity scores. Adjust the similarity threshold parameter to be more lenient or stricter depending on the desired level of precision in the retrieved results. Explore using a different embedding model that produces more relevant embeddings for the specific domain or use case. Consider models known for their ability to capture nuanced semantic relationships. Langchain Google Vertex AI Vector Stores Vector Search Vector Store Data Store Summary. A method for storing and retrieving embeddings using the Google Vertex AI platform. This approach enables efficient similarity search by leveraging the power of vector databases. Inputs. The data that needs to be embedded. This could be text, images, or any other type of data that can be converted into numerical vectors. The format should be compatible with the chosen embedding model. For example, if you are using a text embedding model, the data might be a list of strings. A unique identifier that identifies the Google Cloud Platform project where the Vertex AI resources will be created and managed. For instance, my project ID 1234 represents a specific GCP project. The geographical location of the Google Cloud region where the Vertex AI resources will be provisioned. This could be a region like US Central 1 or Europe West 1, representing specific geographic zones where the infrastructure will be located. A descriptive name that uniquely identifies the Vertex AI endpoint within the specified project. This name could be something like embedding endpoint or text similarity model to clearly indicate the purpose and functionality of the endpoint. Outputs. An object representing the vector store, which acts as an interface for interacting with the stored embeddings and performing vector similarity searches. This vector store object provides methods for adding new embeddings, retrieving existing embeddings, and searching for similar embeddings based on a given query. Steps. Creation of a Vertex AI endpoint, which acts as a centralized point for deploying and serving machine learning models. This step involves configuring the endpoint with the desired settings and resources, such as the model type, deployment configuration, and scaling options. Deployment of a model to the created endpoint. This involves uploading the trained embedding model to the endpoint and configuring its deployment settings. The model will be made available for inference through the endpoint, allowing applications to request embeddings and perform similarity searches. Prerequisites. A Google Cloud Platform GCP project, which serves as the primary organizational unit within Google Cloud for managing resources and services. The unique identifier for the GCP project, which is a mandatory parameter for accessing and managing resources within the project. For example, my project ID 1234 identifies a specific project. The Vertex AI Application Programming Interface API enabled. This involves activating the Vertex AI API service within the GCP project, granting access to its functionalities and allowing applications to interact with Vertex AI resources. The Vertex AI API should be enabled within the GCP project to allow access to its features and functionalities. Fine-tune parameters. The dimensionality of the embedding vectors, representing the number of features used to represent each data point in the vector space. This parameter is determined by the chosen embedding model and influences the complexity of the vector representation and the efficiency of similarity searches. The batch size used during the processing of embedding data. This parameter controls the number of data points processed at once, influencing the efficiency and memory usage of the embedding process. It is important to balance the batch size with the available resources and computational capacity. Challenges and fixes. Issues encountered during the creation of the Vertex AI endpoint, which may be caused by incorrect project settings or insufficient permissions. Review and verify the project settings, including billing configuration, quotas, and permissions, to ensure that they are properly configured for endpoint creation. Errors encountered during the deployment of the embedding model to the Vertex AI endpoint, potentially caused by model incompatibility or configuration issues. Thoroughly verify the compatibility of the embedding model with the Vertex AI endpoint, ensuring that the model architecture, input-output format, and deployment settings are aligned. Problems related to authentication and authorization when accessing Vertex AI resources, including insufficient credentials or incorrect permissions. Ensure that the appropriate credentials are set up and configured for the application to authenticate with Vertex AI and authorize access to the necessary resources. Discrepancies between the embedding dimension of the data and the model, leading to errors in embedding creation or similarity searches. Maintain consistency in the embedding dimension by ensuring that the data and the embedding model use the same dimensionality for their vector representations. This consistency is crucial for accurate similarity comparisons and avoids potential issues during processing. Langchain Google Vertex Model Garden Chat Anthropic Vertex Summary. This YAML document outlines the integration of Anthropic's Claude 2, a powerful language model known for its conversational abilities, into LangChain for Vertex AI, a platform designed for building and deploying AI applications. This integration empowers developers to leverage Claude 2's conversational prowess within their Vertex AI applications. Inputs. Text prompt for Claude 2. The text prompt serves as the input to Claude 2. This prompt can be a question, a request for information, or a creative writing prompt, guiding the model to generate a response. Outputs. Claude 2's response to the prompt. This refers to the output generated by Claude 2 in response to the input text prompt. The output can be a coherent and informative answer, a creative text piece, or a summary of information, depending on the prompt's nature. Steps. Define an Anthropic wrapper. This step involves creating a wrapper class or function to encapsulate the interaction with the Anthropic API. This wrapper simplifies the process of calling Claude 2 and handles communication with the model. Create a LangChain chain that utilizes Anthropic. This step involves constructing a LangChain chain that incorporates the previously defined Anthropic wrapper. This chain orchestrates the interaction with Claude 2, allowing users to interact with the model through a LangChain interface. Prerequisites. Vertex AI Application Programming Interface Credentials. Accessing Vertex AI requires authentication using credentials, typically obtained from Google Cloud Platform. These credentials provide the necessary authorization to interact with the Vertex AI platform. Vertex AI Instance. A Vertex AI instance serves as a managed environment for deploying and running machine learning models, including Claude 2. It provides infrastructure, resources, and tools for model training, deployment, and execution. Fine-tune parameters. Claude 2 model parameters, such as temperature and max tokens. Claude 2 offers various parameters for controlling its behavior and output generation. Temperature influences the model's creativity and randomness, while max tokens limits the length of the generated response. Challenges and fixes. Anthropic Application Programming Interface Rate. Limiting the Anthropic API has usage limits to prevent abuse and ensure fairness. These limits may restrict the number of calls you can make within a specified time frame. Implement exponential backoff to handle rate limiting. Exponential backoff is a strategy used to handle rate limiting. When an API request is rejected due to rate limits, the backoff strategy increases the waiting time between subsequent requests exponentially. This helps avoid further rate limiting by giving the API time to recover. Error handling for Anthropic application programming interface calls during API communication. Unexpected errors can occur. These errors might be due to network issues, API service interruptions, or invalid requests. Catch and handle exceptions from Anthropic application programming interface calls. Implementing robust error handling involves catching and gracefully handling exceptions that may arise during API calls. This can include logging errors, retrying requests with backoff mechanisms, or providing informative error messages to users. Summary of langchain. Google Vertex AI Vector Stores. Vector Stores: Vector Search, Vector Store, Data Store. A vector store implementation for embedding data in Google Vertex AI. This allows you to store and retrieve text data based on its semantic meaning, enabling powerful applications like question answering, document search, and recommendation systems. Inputs: text data, the textual content you want to embed and search within. For example, this could be a collection of documents, articles, or product descriptions. Embedding function: a model that transforms text into numerical vectors representing its semantic meaning. Examples include sentence transformers models like OLMPNet Base 2, or custom models trained on your specific domain. Outputs: embedding vectors, the numerical representations of your text data, created by the embedding function. These vectors capture the semantic relationships between different text snippets. Search results when querying for similar data. The vector store returns a list of text items that are most semantically similar to your query, based on the distances between their embedding vectors. Steps: create Vertex AI endpoint. Set up a Vertex AI endpoint, which will serve as the entry point for your embedding function and data indexing operations. Deploy embedding function. Deploy your chosen embedding function to the Vertex AI endpoint, making it accessible for vector generation. Index data in Vertex AI. Ingest your text data into the Vertex AI vector store, creating an index of embedding vectors for efficient search. Search for similar data. Query the vector store with new text to find the most relevant items based on semantic similarity. Prerequisites: Google Cloud Project. A Google Cloud Platform project is required for using Vertex AI services. Vertex AI application programming interface. Enable the Vertex AI API. Needs to be enabled in your Google Cloud project to access its functionality. Vertex AI service account. A service account with the necessary permissions to access Vertex AI resources. This account needs permissions to create and manage endpoints, deploy models, and access data within your Vertex AI project. Fine-tune parameters. Embedding model. You can fine-tune the embedding model used for vector generation to improve its performance on your specific data. This involves training the model on a dataset relevant to your use case. Index parameters. Configure the parameters of the vector store index to optimize search speed and accuracy. This includes factors like the number of dimensions in the embedding vectors, the indexing algorithm used, and the distance metric used for similarity calculations. Challenges and fixes. Error during deployment. Deployment errors can occur due to incorrect configurations or dependencies. Check deployment configuration. Review your deployment configuration for any errors or missing settings. Ensure the correct version of the embedding model, necessary libraries, and service account credentials are Specified. Slow search queries. Slow search performance can be caused by factors like large datasets, inefficient indexing, or poorly optimized embedding vectors. Optimize index parameters. Experiment with different indexing parameters, like the number of dimensions, indexing algorithm, and distance metric to improve search speed. Consider using a more efficient indexing algorithm or pre-filtering data to reduce the search space. Data size limitations. Handling large datasets can pose challenges for storage and indexing. Use data sharding. Divide your data into smaller chunks or shards, which can be indexed separately. This allows for more efficient indexing and search, especially with large datasets. Cost optimization. Using Vertex AI for embedding and search can incur costs. Use Vertex AI pricing models. Explore Vertex AI pricing models to understand how costs are calculated and optimize your usage. Consider using free tier options if available, or choosing cost-effective instances for your workload. Langchain. Google Vertex Vector Stores. Vector Stores. Vector Search. Vector Store Summary. A vector search vector store class for Google Vertex AI that leverages Google's powerful vector search capabilities for efficient retrieval of relevant documents based on their semantic similarity. This class allows users to efficiently store and retrieve vector representations of documents using Google's Vertex AI platform. The vector representations capture the semantic meaning of the documents, enabling more accurate and relevant search results. Inputs. A list of documents to be indexed. This list represents the collection of documents that you wish to make searchable. Each document in the list should be a string containing the content you want to index. For example, you could provide a list of news articles, blog posts, or product descriptions. The endpoint to your Vertex AI deployment. This is the URL of the deployed Vertex AI model that performs the vector search. The endpoint is essential for connecting to the vector search functionality provided by Vertex AI. Outputs. A vector search vector store instance for storing and retrieving vectors. This instance acts as a data store for the vector representations of the documents. It enables efficient storage and retrieval of vectors, facilitating fast and accurate search queries. A vector representation for each document. Each document in the input list is transformed into a vector that captures its semantic content. These vectors are then stored in the vector search vector store instance, allowing for similarity-based retrieval of documents. Steps. Initialize a vector search vector store instance. This step creates an instance of the vector search vector store class, which will be used for storing and retrieving vectors. The instance is initialized with the necessary configuration parameters, including the Vertex AI endpoint and other relevant settings. Index the documents using the specified Vertex AI deployment endpoint. This step involves sending the list of documents to the Vertex AI endpoint for processing. The endpoint generates vector representations for each document and stores them in a vector search vector store instance. This process enables the search functionality based on semantic similarity. Prerequisites. A Vertex AI deployment with a vector search model. This refers to a deployed machine learning model on Google Vertex AI that is specifically designed for vector search. The model should be capable of transforming textual content into numerical vectors, enabling efficient similarity-based search. Your Vertex AI project must be configured with the necessary application programming interfaces. Keys and service accounts. To access and use Vertex AI for vector search, your project must be properly configured with the appropriate application programming interface. Keys and service accounts. This ensures that your project has the required permissions to interact with Vertex AI services. An instance of a Vertex AI endpoint. A Vertex AI endpoint is a specific resource on Vertex AI that provides access to deployed models, including vector search models. The endpoint acts as a gateway for interacting with the vector search capabilities of Vertex AI. The endpoint should be configured to use a vector search model. The endpoint must be configured to point to a deployed vector search model. This configuration ensures that the endpoint is connected to the correct model and can process requests for vector search operations. Fine-tune parameters. Top k number of nearest neighbors to retrieve. This parameter specifies the number of most similar documents to return in response to a search query. For example, if top k is set to 10, the search results will include the 10 most similar documents based on the provided query. Similarity metric for measuring similarity. This parameter defines the method used to calculate the similarity between vectors representing documents. Different similarity metrics can be used depending on the specific application and the desired results. For example, you could use the cosine similarity metric to measure the angle between vectors, or the Euclidean distance to measure the distance between vectors. Challenges and fixes. Incorrectly configured Vertex AI deployment. A common issue is incorrect configuration of the Vertex AI deployment, including invalid application programming interface keys or incorrect settings for the vector search model. Verify deployment configuration and application programming interface keys. To resolve this issue, carefully check the configuration of your Vertex AI deployment. Ensure that the application programming interface keys are correctly configured and that the deployment settings match the requirements for the vector search model. Insufficient vector search resources. If your Vertex AI deployment lacks sufficient computational resources, it might lead to slow performance or errors during vector search operations. Increase Vertex AI resources and adjust deployment settings. To address this challenge, consider increasing the computational resources allocated to your Vertex AI deployment. You can also fine-tune the deployment settings to optimize performance for vector search operations. Langchain Google Vertex Vision Models Vertex Image Generator Chat Summary. This model leverages the Google Vertex AI Vision Application Programming Interface API to create visual representations based on textual descriptions. This means you can input a sentence or phrase, and the model will produce an image that corresponds to the text provided. Inputs. The text prompt is the core of the image generation process. It serves as the instruction for the model, outlining what the generated image should depict. A clear and detailed prompt will lead to more accurate and refined image outputs. For example, a prompt like a majestic lion roaring in a lush savanna will yield a significantly different image than a cute puppy playing with a ball. The image size refers to the dimensions of the generated image, usually expressed in pixels, e.g., 512 by 512 or 1024 by 1024. This parameter allows you to control the resolution and overall scale of the output image, impacting its detail and visual clarity. For example, a larger image size might be suitable for high-quality prints or detailed artwork, while a smaller size might be ideal for web display or quick previews. Outputs. The output of the Vertex AI Vision model is a generated image. This image is a visual interpretation of the provided text prompt, created using the model's deep learning capabilities. The output image can be saved in various formats, such as JPEG, PNG, or WebP, allowing for flexibility in its usage. The quality and style of the generated image are influenced by the prompt specificity, the model's training data, and the chosen image size. Steps. The first step in the image generation process involves processing the text prompt. This step involves breaking down the prompt into meaningful components, analyzing its intent and context, and translating it into a format that the model can understand and process. The model might use techniques like natural language processing (NLP) to understand the prompt's meaning and extract key elements for image generation. After processing the text prompt, the model sends a request to the Google Vertex AI Vision API. This request includes the processed prompt and any other relevant parameters, such as the desired image size and style. The Vertex AI Vision API then utilizes its powerful deep learning models and image synthesis techniques to generate an image based on the provided information. Finally, the Vertex AI Vision API sends back the generated image to the user. This image represents the visual interpretation of the provided text prompt. The user can then view, save, or further process this image based on their needs. The quality and accuracy of the generated image depend on the complexity of the prompt, the model's training data, and the chosen image size. Prerequisites. A Google Cloud project is essential for using the Vertex AI Vision API. This project acts as a container for your resources, including your Vertex AI models, data storage, and API keys. Setting up a Google Cloud project involves creating a new project within the Google Cloud Platform (GCP) console, providing a unique name and setting up appropriate billing options. The project ID is a unique identifier assigned to your Google Cloud project. It's used to distinguish your project from others and is essential for accessing your resources. Within GCP, you can find your project ID in the GCP console or in the project settings. The project ID is critical for authenticating your API requests and ensuring that you are interacting with the correct resources. Enabling the Vertex AI API is necessary to access the Vertex AI Vision models and services. This process typically involves activating the API in your Google Cloud project through the GCP console. Enabling the API allows your project to make requests to Vertex AI and use its functionalities. Once enabled, you can start using the API's resources for tasks such as image generation, object detection, and image analysis. An API key is a unique string that grants access to the Vertex AI Vision API. You can obtain an API key from the GCP console, where it's generated specifically for your project. The API key is used to authenticate your requests and ensure that you have the necessary permissions to interact with the API. It's crucial to protect your API key and avoid sharing it publicly, as unauthorized access could potentially compromise your project's security. A Vertex AI Vision model is a pre-trained or custom-trained machine learning model specifically designed for visual tasks. These models have been trained on vast datasets of images and labels, allowing them to recognize patterns, generate images, and perform other visual-related tasks. When using the Vertex AI Vision API for image generation, you'll need to choose a suitable model that aligns with your specific requirements. The model's capabilities and training data will influence the quality and style of the generated images. Fine-tune parameters. Image resolution, often expressed in pixels, e.g., 1024 by 1024 or 2048 by 2048, determines the sharpness and detail of the generated image. Higher resolutions allow for greater detail and visual fidelity, while lower resolutions might be more suitable for web display or quick previews. Choosing the right resolution depends on your specific use case and the desired image quality. Image style refers to the visual aesthetic or artistic approach applied to the generated image. This can include elements like color palette, brush strokes, or specific artistic styles like impressionism or abstract art. You can control the style by providing additional information in the text prompt or by using a pre-trained model designed for a particular style. The image style can significantly impact the visual appeal and interpretation of the generated image. Challenges and fixes. An API key authentication error arises when the provided API key is invalid or has expired. This can happen if the API key was generated incorrectly, has been compromised, or has reached its expiration date. To resolve this, you need to check the API key's validity and ensure it's properly configured for your project. You can regenerate a new API key in the GCP console or verify the existing one's status. To ensure the API key's validity, you need to double-check its correctness and confirm its status within the GCP console. This includes verifying that the API key is properly associated with your project and has not expired. You can also try regenerating a new API key to address any potential issues with the existing one. Model not found occurs when the specified Vertex AI Vision model doesn't exist or is not accessible. This could be due to a typo in the model name, a missing dependency, or a problem with the model's availability. To resolve this, you need to verify the model name and confirm its availability within the Vertex AI platform. Ensure that the model is correctly configured, has the necessary permissions, and is accessible to your project. To verify the model's name and availability, you need to refer to the Vertex AI console or documentation. Double-check that you are using the correct model name, and ensure it's available within your project. If the model is missing or inaccessible, you might need to redeploy or configure it correctly to resolve the issue. Image generation failure can occur due to several factors, including an ambiguous or unclear text prompt, limitations in the model's capabilities, or improper parameter settings. This could result in an image that doesn't match the desired outcome or a complete generation failure. To resolve this, you need to analyze the prompt, adjust parameters, and potentially explore different models to find a better fit for your requirements. To address image generation failures, you should start by reviewing your text prompt. Ensure it's clear, detailed, and specific enough for the model to understand your intent. Experiment with different prompt variations to find one that generates a more desirable output. Additionally, adjust parameters like image size, style, and resolution to find an optimal setting for your needs. If the issues persist, try exploring other Vertex AI Vision models that might be better suited for your specific requirements. Langchain Google Vertex Vision Models Vertex AI Visual Q&A Chat Summary. This describes a langchain tool that is designed to interact with Google Vertex AI Vision models for the purpose of answering questions related to images. Inputs. This represents an image that is provided as input to the tool. The image is used by the Vertex AI Vision model to understand the visual content. This refers to a question that the user asks about the provided image. The tool utilizes the Vertex AI Vision model to find an answer to this question based on the image. Content. Outputs. This represents the response generated by the Vertex AI Vision model in answer to the user's question. It's a textual answer based on the image in question. Steps. The tool starts by loading the provided image into its memory. This step involves retrieving the image data and making it accessible for processing. The tool then sends the loaded image and the user's question to the Vertex AI vision model. This involves transmitting the image and question data to the model for analysis. The tool receives the answer from the Vertex AI vision model and delivers it back to the user. This entails retrieving the response generated by the model and presenting it to the user. Prerequisites: a Google Cloud project is needed for utilizing Vertex AI services. This involves having an active Google Cloud Platform project with the necessary permissions and resources for accessing Vertex AI. A Google Cloud project is required to utilize the Vertex AI Application Programming Interface (API) for accessing and interacting with the models. To interact with the Vertex AI models, an active API key is necessary, which authenticates access to the API and allows the tool to send requests. This refers to a trained Vertex AI vision model specifically designed for answering questions about images. This model is capable of processing and understanding the visual content of images and providing meaningful answers based on the information present in the images. A Vertex AI vision model that specializes in answering questions based on image content is a crucial component of this langchain tool. It's trained to extract relevant information from images and use it to answer questions accurately. Fine-tune parameters. This parameter refers to the type of Vertex AI vision model being used. Different model types have varying capabilities, such as question answering Q&A or image classification. The specific model type determines the type of questions it can answer and the level of detail it can provide. This parameter represents the size of the Vertex AI vision model being utilized. Larger models generally have better performance and can handle more complex questions, but they require more computational resources. Smaller models are more lightweight and efficient but may have limitations in handling complex tasks. Challenges and fixes. In some cases, the Vertex AI vision model may not be able to provide a completely accurate or relevant answer to the user's question. This could be due to various factors, including ambiguity in the question, limitations in the model's understanding of the image, or the presence of complex concepts that the model may not be fully trained to handle. To address this, one approach is to try rephrasing the question. By rewording the question, the user can make it clearer and more specific, potentially leading to a more accurate answer from the model. Another strategy is to provide more context in the question. This can help the model better understand the user's intent and provide a more relevant response. The Vertex AI vision model may struggle to fully comprehend the visual content of certain images, especially those containing intricate details, complex scenes, or unusual imagery. This can result in the model providing inaccurate or irrelevant answers to questions related to the image. To overcome this challenge, one approach is to experiment with using a different image. Selecting an image that is clearer, simpler, or more representative of the subject matter in question can improve the model's understanding and lead to more accurate responses. Another strategy is to use a more specific question. This helps to narrow down the scope of the query and focus the model's attention on the relevant aspects of the image, potentially leading to a more accurate answer.